Hello and welcome to ZaranTech exclusive SAP Manufacturing PP training on S4HANA, the industry's leading solution for optimized production processes. SAP Manufacturing PP on S4HANA revolutionizes production planning and execution. Seamlessly integrating with other S4HANA modules ensures real-time visibility into your manufacturing operations. This solution empowers your organization to achieve operational excellence from demand forecasting to resource allocation and production scheduling. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now let's take a look at the agenda. Number 1. History of S4HANA. Number 2. Roadmap. Number 3. SAP S4HANA Innovation. Number 4. SAP S4HANA Lines of Business. Number 5. SAP S4HANA Deployment Options. Number 6. Subcontracting in S4HANA. Number 7. Demand-Driven Material Requirement Planning DDMRP. And number 8. MRP Procedure Changing in S4HANA. Let's dive into the video now.
So the topic starts with the first topic is introduction to S4HANA. I am working in the production planning area. Actually, I am from industry. I did not ask you this thing, whether you are straight into SAP or you have worked in industry before doing this SAP consultation. So I have done 17 years in domain before migrating to SAP. So 2005 till now, I am in SAP. So I have started with plant maintenance and then I shifted to production planning very soon. And I have been doing plant maintenance, mainly production planning, QM and WMMM also, and EWM, this area for the last 15 years. So I have worked with IBM, HCL, even TCS projects I handled earlier, and now mostly I'm working with US-based clients, directly with the US clients. In S4HANA, I've been working for the last 4 years. So total, I'm having 31 years experience in industry, out of which 17 years in domain and 15 years in SAP consulting. Implementations I have done around 6-7 implementations I have done in production planning and along with support projects, and so is in plant maintenance and QM also. So this is my brief introduction. So this presentation, including examples, images and references, are provided for informational purpose only. Please, I have to go through this slide. So that is why complying with all applicable copyright laws is the responsibility of the user. Without limiting the rights under copyright, no part of this document may be reproduced, stored, or introduced into a retrieval system or transmitted in any form. This has to be remembered, and or by any means. Credit shall be given to the images taken from open source and cannot be used for promotional activities. So the next slide is the agenda for this particular slide, which tells about the history of S4HANA, the roadmap, the S4HANA innovations, S4HANA line of business, and the deployment options. SAP added machine learning. These things are actually just theoretical, because as a PP consultant, I don't go through all these things, but these are the things that have been mentioned in the history of S4HANA. Easier goods and invoice receipt reconciliation to automate invoice assignments. In September of that year, transportation management functionality was embedded in S4HANA. In 2018, predictive accounting functionality was added, and subsequent release, the solution included additional intelligent technology enhancements in the areas of artificial intelligence, blockchain, and Internet of Things. The whatever is written here, I am not associated with. If anybody of you know about these things, these are different areas, not production planning, but in other areas where the changes have taken place, it's mentioning that only. Now the implementation can happen in a cloud or on premises, that we know. So there are so many steps that are followed by the basis team and our ABAP team, and then individual module owners, while migrating from one type of say ECC system to S4HANA, depending on the type of implementation that you are doing, whether it's a green field or a brown field, or a new thing that is called a blue field implementation that I did in IBM. So for faster faster migration. So what is the new functionality? Mainly what I have seen is that in the FI area, prior to migration to S4HANA, there are pre simplification steps that need to be carried out. First thing, the simplification items, we need to find out whether our existing system on which we want to convert to S4HANA has, is suitable, or we need to do some work on that, upgrade to HP7, or do other kind of Unicode compliance on that system, and what are the simplification items that are um, that are applicable, and what are the items that will not support when we migrate to S4HANA. So in the FI area, there are a lot of changes at that present, because pre and post migration activities, there are so many, and that is absolutely new. So unless that is done, then we cannot move anything, in any of the modules. So this is for 2020. So in the simplification list, you have the items for each of the modules, as well as the basis and master data or everything. Say, for example, in the production planning area, you can see that there are simplification items. So when you are migrating to S4HANA, you have to go through these items. When you run that simplification check, that gives you a list of things that are applicable to your system for migration. So from there, so that means those are the items that you need to look at. So here, in the production area, you will find that there are simplification items. This is PLM, PM, this is the PP. So these are MRP in S4HANA. So if you look at this, there is a note, corresponding note. So you have to go through this note. These simplification items are when items or notes, those which has to be installed, are basis activities when they run this transaction. And those they select and install when they are installing the server as a pre-installation activities. And post installation, after it is converted, after Unicode conversion and custom code remediation, these things will be activated. For some manual configuration may also be necessary, depending on the client situation. In every lines of business, like finance, as we are seeing in that simplification list, all the changes that have taken place and relevant notes have been mentioned. So next slide is the deployment options. In deployment option, we can deploy in the cloud, or we can have it on the on premises. Actually, cloud implementation, I have not implemented, but transferring or migrating to Amazon cloud from existing on premises, that I have done with one client. So entirely this thing has not been, this is not basically related to our functional area, but only thing is that after the basis activities are done, we have to do the testing part once it is in cloud, whether the standard functionalities and even the Z programs are working correctly. This part you have to do, from a functional point of view. And if it is an on-premises edition, that I have already told you, that from ECC, our step is to check the current system and the applicability of the simplification items by running the simplification check first, which will give you a list. And then we have to do the S4HANA conversion pre-checks. And also, one of the things is the Unicode conversion. That means it has to be Unicode Unicode. We have to convert. If it is less than ECC 7, then first we have to just upgrade it to EHP 7, and then we have to do the Unicode adjustment, and then custom code remediation. And after that, we can migrate to S4HANA box, and then we do the Z code conversion. Because Hanatization or remediation of the Z code is necessary because of the table alignment has changed. So these are the things that we have to do from the basis and above side first. And after that, we do the testing. And finally, we do the master data migration. It depends on the type of project. Whether it is a greenfield project, greenfield implementation, or it can be bluefield implementation. I will give some input on this. Like brownfield implementation is basically a table-to-table copy. What we had in ECC is exactly the same thing without any changes. Even if S4HANA offers additional functionality, we don't do. We just do the pre-checks and do a table-to-table copy of all master data and configurations, and do the migration in S4HANA with no changes. So this is one type of implementation. Greenfield is as if we are not having any previous ECC system, and we built everything in the S4HANA side using this Activate technology. And greenfield is bluefield is a new technique that I have seen. I have used also in one of the projects, where what happens is that they establish the S4HANA database, and but before that, they create an empty shell of copying only the configuration from the ECC side into an empty shell, which is still an ECC box, and all the configurations are copied. So after that, they do this Unicode conversion and Z code remediation, and then they establish the S4HANA server, where we now have all the configurations for ECC. That means we don't have to do any configurations. Like in Greenfield, we have done all configurations, and also the master data migration, and then testing everything as if we are doing a new project altogether. So that is our greenfield. But in bluefield project, we are just as it is, we are just copying only the configurations, not the master data. And after those remediation and Hanatization and Unicode conversion, we establish the S4HANA box, and there we do the master data migration. The master data migration, again, for migration to S4HANA, there is a separate tool. We can give that tool, or there are many third-party softwares. Like one company, SNP, is there, who has this own software for master data migration from ECC to S4HANA, that they do by table-to-table copy. So then this happens, and finally, whatever pre and post manual configuration activities we do, and then we do the testing and go live. Advantage of bluefield is that it is done since the configurations are done. Automatically are copied beforehand, so the time taken is much less, and also the master data migration time taken through these special tools are less. Otherwise, this master data migration we have to do using our standard BDC or LSMW, or in S4HANA. We have this LTMC and LTMOM, right? Just downloading the file, standard template, creating a project, then filling up the data. Maybe there are 4 or 5 sheets, like in the example of routing, say. So we have the header, then material assignment, the operation, component allocation, and QM characteristics. So these 5 tabs are there. We fill up the data, and then we follow 3 or 4 steps, like updating to the staging table, then do the mapping, and if there is any gap, then we supply the ISO code or whatever gap which is showing after the mapping, and then we do a simulation and finally update the tables. This is we have discussed regarding the brownfield and bluefield and greenfield, but there is this hybrid that they are saying that this is basically a match between the brownfield and greenfield implementations, but certain things are as it is copied to S4HANA, and certain things that we need for improvement can be taken into account, and we can leverage the benefits of S4HANA. So the next one, so this is the implementation methodology in S4HANA. So I'll again have to tell you this first three slides. So this is again the same thing I'm repeating. This is the disclaimer part. Just go through this. Same thing that we did for each slide. Each presentation will have these three slides. So again, this disclaimer is there. We have to note these things. And then the next one is the agenda. So it is talking about in some detail about the implementation methodology and in S4HANA migration methodology. In general, what we have done in ECC, that is our old implementation methodology, and then the S4HANA migration methodology using mostly the Activate methodology. So you can see that the clarify scope of implementation, decide on the scope of implementation. Suppose, for example, we go in with a utility company, and this utility company will have, say, say power utility. It has generation, distribution, and transmission and distribution, and as well as billing, IS utility part. So here we decide and discuss and decide on the scope. That is whether we'll do only the generation part or transmission part or distribution or all at a time. So and within that, what functionalities will implement and which will be part for later implementations. So that is the scope. So we form the team that is from each side, the SAP partner side, like TCS, and from the client side, and we'll have the steering committee members and the project sponsors from the client side. Then we have the core project team, and the consulting team. And the sequence of project implementations. Going forward, how we'll start like our as study and gap identification, to be study, then realization, different testing, that will come later. Establishment of the servers, the timeline, what will be the number of users that we have to consider. All these things are discussed and decided in the project preparation. Then we have the project kickoff. So the first phase is not the business blueprint. First phase is basically, that is the phase two, is not only the prior to making the business blueprint, we have to do the as is study. There is existing system for the client based on the scope. We have to study the existing processes, including everything. Master data, the processes that are run, the crucial reports, all these things we study, and then we create this business blueprint by identifying the gaps in the standard SAP process, what is available, and then we note these gaps and how we remediate these gaps, whether these gaps will be there or not, or whether that will be treated as a gap or not. And all these things are documented and finalized in the business blueprint. So this business blueprint contains, as I have told you, see, this content, it contains the organization structure part, that is for plant maintenance or production planning. Whatever areas you are working in, this is the structure of the blueprint. you have a organization structure part, then you have a master data part, then you have a business process, which you list down. Um, like in the production planning area, our organization structure will contain all these things: control, company client, company code, controlling area, then mainly the plant, production plants, and the storage locations. And if WM is there, we can also mention this WM linked storage locations, which are WM enabled, and under WM again those storage types, storage sections, warehouse numbers, all will come into play. All the organization elements that we have to maintain under organization structure. Next is this master data part. So we have to maintain, mention all these master data in production planning, like material master, BOM, work center, routing. But production version is now absolutely mandatory in S4HANA. So we have to maintain the production version also. If it is a PPPI, then we have to maintain the, mention the um, master recipe and resources. Then we have to mention the business processes, and again each process, what is the current process, what will be the would-be solution, and what will be the, how it will be, in case there is any gap, we'll also uh, uh, mention this gap, and we'll discuss the possible solution. After the business process, we have the integration, which happens in SIT and UAT. System integration testing and user acceptance testing, when we run the integration cycles. Like in production planning area, what are the integrations with, say, or WM, EWM, or FI that we have to run, and the total cycle. So these are the integrations we have to mention, and the RISEP objects. The RISEP object will contain the workflows. Workflows in production planning are not generally there. Mostly it is not there. So we don't have workflows, but we have reports which are not available in standard but crucial to the customer. So that reporting need has to be understood, and it has to be noted. And we have to develop these reports through our functional spec. We have to share with above developers, and then we have to write these reports. So customization is basically customization. Normally SAP is 70% pre-configured, but based on client requirements, we are doing some configurations. We do this say order type configuration or MRP group. Whatever we think that it is required for the client requirement, that we do. Suppose in our case, we know that in a goods movement, in the production order confirmation screen, when we put that scrap and rework field, these are not posted anywhere, isn't it? Only the yield is posted. So if I want to see that these are also posted in a report where it is going, we can only see in the confirmation table, approve table. But if I want to see the posting, in MMB also, if I want to see it as a stock. So if we have to modify our posting or goods movement, I'm just giving you an example. There is body which can do this. Or in the confirmation screen, we can add custom fields. So there is user exit for that. So if certain things need to be checked before we save a production order or a process order, then also we can use these user exits. So these are the parts of enhancements that are done, right? So apart from that, there are forms and printouts, like they have to issue some soft paper or pick list. So for that, their format their format may be different from the standard SAP script that we are having as SAP script. So for that, we have to write the functional spec based on their form. So for that, the screen painter is necessary. Any screen exit that might be necessary for data entry to capture those fields. And accordingly, we have to write the functional spec and give it to the ABAP team for developing the fields and what needs to be populated and in which logic. So these are the RISEP objects that we list out, and we also maintain in the business blueprint. And finally, after all things, if certain processes or maintenance of master data or anything can be seen as not being met with after all these RISEP objects or standard SAP or workaround, we treat this as a gap, and that we decide during our blueprint presentation and final decision making how to go about it. So this is basically the content of a blueprint. Let us say I go to any of this section, just an example. Say example, this is a plant maintenance example, production planning example. Let me see if I have one. See, there are other clients where the BBP can be many ways. This is one BBP that I am showing TCS. This one is a comprehensive BBP that contains all the sections like as is study, then the master data, process, RISEP, audit reports and gaps, everything. But you can also have a process type, process-wise BBP. For example, in one of the clients, I will show you a BBP for a make-to-order scenario. So this is a production planning blueprint in ECC 6 that is for a make-to-order scenario for another client. So this will contain this. This is a process-wise BBP. So you have the process steps in the BBP. You mentioned the process steps. And you have the flow chart of the process for make-to-order production. And you finally enter the gap analysis. The process steps that you mentioned in the BBP will contain how they are executing the process and how this will be mapped in SAP. This is one way of making BBP. It is a process wise. For my side, I can say that it is better to have a process wise BBP. I mean, that is my experience. Instead of having a big BBP containing all the processes, the earlier one. So in this, you mentioned the as-is and how it will be done process-wise, or the master data-wise, or the organization structure-wise. This type of BBP is better because you also need to run the BBP workshop at the at the end of the when you complete the BBP, and there will be question answer sessions. Have you ever run any BBP workshop?
Yes, Deepak will do.
Yeah, so there we finally, once we actually the BBP is prepared in conjunction with the super users and also end users. So once everything is ready, we present it to the steering committee or the meeting, or a workshop. It can be a whole day workshop, or it can be process wise. We can have scheduled sessions for the workshops. And after each process is discussed and decided and finalized, we freeze that, and finally we give it to them for sign off. After the BBP, the next phase is the realization phase. In the realization, what we do, what is after the BBP is signed off and everybody has agreed to the mapping, we do the mapping. We create the organization structure. For that, necessary configurations are done. Then we do the master data related and process related basic configurations. And after that, we do a unit testing. That means whether within the module itself, whether we are able to create a full say production order, whether it is getting created, whether one MRP run is happening. So this is the baseline. After the baseline is done, we can do a final configuration with the customer's input to fine tune what we have done. So basically the baseline configurations and unit testing are done here and finalized. That we do in a golden client. There are two clients in the development normally. One is the golden client where we do only the configurations when no data is there, and we transport everything from golden client to the quality client, quality server. So in the golden and there is one sandbox where we do all sorts of testing before once we do the configuration and try to align with the process and whatever we have finalized in the BBP. So that is the sandbox where we do all kinds of testing with some of the representative data from the customer with their data. So that is how the first phase, that is of the realization, that takes place. In the development system, we do this part. The final, but now after that, when the quality client is set up and when our configurations and testing are done, I mean unit testing, and then we do system integration testing, that is SIT, then we will move our configuration once everything is accepted from our side. We move everything to the quality server. We can have two quality clients. One is the where we upload the data, say about 50% of data or 75% of the client data, and do a full testing with the same configurations that has been fixed and finalized. So that is one part, and there we have a UAT also from the client. So we prepare the test scripts and we give it to the client. We have the test scripts. I'll share some template test scripts with you where the process steps are there with the transaction codes. Let us consider a test script which is SAP standard test script. So this is a Word document, but this is as per the best practice. In our case, this is a Fiori app based test script. This test script will be, they have structure. I mean, SAP standard test script is this way. This test script will contain this. This is the steps. These are the steps. So you have the test step name, then the test step name, how you carry out either transaction code or it is now mostly Fiori app based, and what is the expected result, actual result, pass fail, who is the tester. So these things, this UAT script we prepare and share with the client. Exactly not in this format, but this is the table where we do. They have given the explanation of each of the steps later on, but we provide this kind of table to the client after we test it and found it as okay. So they carry out the UAT on this script, run the process, and put their comments as pass and fail for further adjustments. If there is some discrepancy or if certain case fail, where we have to correct the master data, say, or any configuration, we go back to the golden, do the configuration, or master data fine tuning we do in quality, and then it is retested. After each and every test script, as per the BBP, is tested and finally passed, then we will be uh, um, going to this next phase, that is the cutover, final preparation. The final preparation will involve testing, system management, cutover activities, end user training, and all other tasks that are required. Now, testing we were discussing. So, for almost with full data before the go live, with full data, we do another round of testing, and then we, as I have told you, that there is another client in quality that is established. There is a training client where we train the users. So there are training manuals or user manuals that have to be prepared, and we carry out the training activities uh, at different locations with the end users and super users. From the production point of view, the cutover means before we migrate to productive system, we have a maybe we have a pre-productive client where 100% of the data from the client is uploaded with full configuration, and we have a mock go live, like uh, they are running their system on SAP parallel to the legacy system, and check that the values are matching. More on the finance and side, in the cutover period, we have a blackout period where we freeze their books, we do the initial upload and all the financial entries that are uploaded and checked with the trial balance that is uploaded, and the balance sheet is checked with the legacy whether those are matching. That happens just before the go live. So we freeze the inventory in those days, and there is no transactions. We upload the MB1C or Amigo, whatever way, in HANA. These old transactions are no longer there. And we do the full data migration also in the productive system. So after all this is done, we are ready for our next phase. That is the go live. After, all the reconciliations are done and the balance sheet is uploaded, we go into a go live, and the system goes live. So what happens? You have the experience of what happens in a go live, and after that, what happens? That when the system is completely starts running in SAP, what happens is that you still have many open orders in the legacy system, which must be I would say, entered in SAP. So that can be done manually, or as well as that can be migrated using tools depending on the data volume. In the production planning area, what we have, there can be some open orders or open production orders at different states. Some can be released or some are already partially confirmed. So all these orders, depending on the data volume, are to be uploaded or created manually and then completed. And this process will go on, say, for example, depending on the data volume, it may go on for another week's time when we are at par with the existing legacy system. That is, we don't have any backlog. And then the support period will go on. The support happens at site initially for, say, 1 or 2 months, whatever the agreement is. And then that is the hypercare period initially. And after that, so every day's incidents and any user lack of understanding or training deficiency, or how they do it in the system, whatever problems they are facing, those things are addressed, and we have a full issue. I mean, that is this is the period where the maximum work happens in the project and the maximum workload comes. After that, when it is somewhat streamlined, we still do support for maybe another 3-4 months. And if the agreement is there to provide support, AMC or that kind, then it can be extended, or yearly we can provide support. I mean, in this, there can be various types. Like we can, there may be certain gaps which can be mitigated by creating a new change request, CR management, where a new request comes and we have to do it, which was not part of the scope of the project, and new billing has to be required. So all these things are done at that stage. So this is the conventional, our normal practice of doing the implementation. In the S4HANA migration strategy, it is actually a little bit different in the sense what SAP has now done is that they do it in a rapid deployment system where you just download the best practice from the best practice explorers and run the system and show it to the client initially. I mean, instead of that, during the blueprint preparation itself, you have just run the process so that they quickly get accustomed to the system at an initial stage, and where if they are having a better understanding at the beginning, they can come up with their suggestion and it can be faster. So basically the process is same, but we do it like the deployment is faster, and the remaining process also follows this pattern. We have 3 sprints: sprints 1, 2, and 3, based on the Azure technique. This is basically the activate methodology. We'll discuss a bit of activate methodology now. What are the different steps which are followed, and how, I mean, these are basically what I find is the different terminologies they are using nowadays. Instead of the SAP, which we have discussed. In the activate methodology, we have again certain phases, like the 5 phases that we have discussed in the standard SAP methodology. In activate, we have basically 6 phases. We have a first phase called discover phase, then we have the prepare phase, then explore, realize, deploy, and run. In the discover phase, that is what I told you, where the customer realizes that there is a need for solution. The business point, it starts looking at SAP for the right solution. So we have a trial solution in place. So you can say that is a client dumping. We have pre-configured solutions which we can show it to the customer. Say for example, in production planning, we have the best practice for chemical industry. Say this best practice chemical company roadmap. So here all the process steps are there. This chemical industry solution map and the relevant test scripts and all these things, these are presented and shown to the client. These are the different processes for sales. If you look at the best practice explorer, all these companies' name which has come up here, including your DuPont or others, they follow this method. This activate methodology was used, using the best practice for chemicals. As we know, in the production planning area, we start with the demand planning. So currently, we are using standard SAP or flexible planning. These and even long-term planning in ECC 6. Same thing is used in S4HANA, but we also have one cloud solution now available, which is IBP, Integrated Business Planning, that has a Microsoft Excel type of interface where we download the sales data and do all optimization and calculations for arriving at a accurate demand data for converting to production. So that is one of the areas that I mean, nowadays it is very much in use, IBP. I don't know how long it will be used. From my personal experience, I can say that I have seen in one CPM implementation, customer project implementation, customer project management. That is basically a PS module ramification. So in that project, I have seen that it is a failure because it was not realized. This Excel sort of, but people are using IBP now, as well as our old SOP system is very much there in S4HANA. These new things, when mostly in Indian industry, we don't see these things, MII application much. But in Europe and US markets, we see that there are strong shop floor control systems for manufacturing execution, which are already available. So there, this MII solution um, comes into play. We have an SAP from which it goes to MII, the middleware via inbound, outbound IDOC, and goes to their MES system. In Europe, Hydra is one popular system where you can create a SAP order, production order in SAP, and through MII system it goes to Hydra. I'll share some template solution for these things, which you can keep as a reference, because all these things cannot be discussed within this short time. Each is a big solution. So it again is get processed in the MII system, Hydra system, comes via MII inbound IDOC to SAP for completion. So this interface and developments, all these things, these are available in a standard template in SAP in a pre-configured solution. You can have a look at any of the best practices, like chemical best practice or anything, and you will find that there are these template solutions, which we first show it to the client in the discover phase, and they have a SAP product experience. So the next phase of this activate methodology is the prepare phase. In this phase, it is both important for the customer and partner to understand, what we have just shown a template, which one is the other crucial activities with respect to the project. So from that, we understand that again, this terminal, this prepare phase, that tells about the identification of crucial resources from the customer side who can work with SAP consultants, and if required, some crucial partner side consultant can be onboarded, and they can work with the SAP consultant who also has knowledge about this system. So initial level of requirement that is gathered already from the business owners, we fill in the business configuration as well as a BC set. You are aware of the BC set? Because when we deploy the best practices, we have the BC sets in notepad files, config file and data file, which we can upload. There is some way of doing this quick uploading and activating the BC sets. So a pre-configured client created that way is shown to the customer. And from there, we just do further changes based on the answers provided by the assessing consultants from the customer, and we move on to the next phase, that is the explore phase. The explore phase is the most important phase. This actually is basically a fit gap analysis, fit to standard. Whatever best practice template that we have shown and discussed and got input from the customer in there is then it's done a fit gap type of analysis, means we realize in the system based on the modification that we do to the best practice when we get the feedback from the customer. And then we do a demo. We'll do a flow chart and a demo to the customer showing what the initial system will look like to the customer. During this feed gap analysis session, which we show to the customer, we can have additional requirements which can be noted, and later we can map this when the actual realization takes place. There is a Fiori link for my what is that? My migration projects. So I exactly name I don't. I'll see when we open that Fiori. So that will open the LTMC cockpit. So there we can download the file. Some file is already ready. So we can try one out. And at this phase, when we are doing this explore phase, the customer will fill up all this data to minimize the time. Base part of explore phase is that the customer execution of standard process. They are already accustomed to the process. So in the explore phase itself, we try to achieve in Activate that they run it themselves. And that is what, I mean, already I have shown you the one SAP standard test script. So this type of test scripts are copied from the standard and provided to the customer so that they run these test scripts in that system. So before the actual testing happens, the customer is already aware of the standard processes. RISEP objects are also noted at this point of time, like workflow report, integrations, conversions, enhancements, and forms. These RISEP objects. The realize phase comes later after the explore phase. The realize phase is more or less the same. It only takes care of the other backlog documents that we note during the explore phase. And we have the quality system for the UAT and further testing, and which gets sign off. Also, we develop the RISEPs, and then we have the some of the RISEPs, not all, maybe not all reports, some crucial reports and the enhancements related to the screen and the process which we develop are also incorporated into our solution at this stage. There is a thing called authorization matrix. So that is basically the different transaction and roles and the number of users. An Excel form that is shared with the client to fill it up on the transaction codes and different roles who will have access to create, change, and display for different transactions and authorization objects. This one tells us about the plan to production process in S4HANA and financial implications of production. So how to, I mean, this slide, this PowerPoint describes the sequence of things that we need to do to run PP. So the steps, like first we have to set up the master data. What are the master data? Master data, we already know that material master, BOM, routing, production version, master recipe or resource. And in repetitive manufacturing, what is the master data? Releasing the order, we release the order, then we can take the print out of shop papers. After our implementation, the shop paper print will be according to the client format, where we have pick list, operation list, job ticket, etc. And then we can, once we release the production order, we'll do goods issue and then do confirmation. The confirmation can be single confirmation, order level confirmation, time event confirmation, post processing, clearing COGI error, or CO 1F for error handling, for failure, the activity posting, and then goods issue, which can be separate or by backflash. So all these things are done, and then once it is done, we do the settlement. We do the variance calculation and the settlement. You have done all this process, right? In variance calculation, how do you set it up? The background configurations of product costing also you are aware of, right? That is the financial implication means GIGR material cost is updated. When you post the confirmation, activity cost is updated. Apart from that, there can be process cost also, like quality cost or any other overhead cost, which can also be updated in the production order. So that is the MMFI configuration, and also the account determination in OBYC. I mean, um, for different transaction types like AUF or BSX, or how you assign the GL accounts, how during transaction the account determination takes place. This basic idea, like, because sometimes this error comes like in the valuation area, you have not set up for the order type and plant. So that error will come during posting. So we'll check all these configurations. So that is the resource cost and material cost. Resource cost is again, we have the formula in the work center copied to the routing. Then that calculates the cost based on the formula, activity type and cost center. We maintain in the work center. We maintain the rate in KP26, and then the cost is calculated. There is no change in S4HANA on this. Overhead cost is again calculated using a costing sheet. That is, we have the base, the overhead percentage and the credit line. So it can be based on a flat percentage of the material or labor cost, or it can be based on a absolute value, which is added to the base cost. Utility, insurance, rent, etc. It depends on the customer requirement, what all overheads we need to consider. Product cost, that means the material costs, are calculated using standard cost estimate run. That is CK40N or CK11N run will do one for one of the materials. So that takes care of the entire routing and BOM. So calculates all the resource and material cost. Do a cost roll up for the raw materials up to the SFG and then to the FG level. And that gives you the final standard cost estimate for the production, for the final product. As you can see that these processes are mostly same as in yeah, but the background setup in FI area done by the FI consultants are quite a lot for this to happen. From the production side, we will not see much difference. I've not encountered any additional problem due to S4HANA in product costing, apart from what we already have. So business blueprint workshop, how to conduct a workshop. It is a structured meeting in which the project team works with the business users to define the business process that will be supported by the S4HANA team, as well as any customization that needs to be done. So there are two things. First thing that I believe that once you go to the customer, we have to have that confidence in the customer that you are one of them, you understand their process. Then you win the confidence. And once you have the confidence, then you have the good SAP knowledge. You can tell them that it has to be done this way only. And since you are doing SAP, you have to do this thing only. And they have to accept that. And that is how you have the you have the control, I would say, and you get your business blueprint signed and done. This cannot be taught, isn't it? But from my personal experience, I can say, since I have worked in 15 years prior to coming to SAP in industries, I have some confidence with the customer already when I approach them. And that is why that helps. Not that most days, most of days, these days what happens is that people working for 2-3 years maximum, maybe they are into SAP, or maybe they just enter SAP as a functional consultant. Consultant is a different thing. They have to suggest a better way of doing their business. Whether you are doing it through SAP or Oracle, that they are using SAP is a different thing. But to run their business in a better way, SAP has given this best practice. But in Indian industry, they may not be best fit. So we have to just balance this best practice with the Indian industry context and give them the best solution. The best solution means two things, what I understand. One is that from the user perspective, it should be a smart solution. It should give you all the crucial reports. That is fine. That the top management sees. But from the user point of view, the ease of use, that is very important. And also capturing of all day-to-day data. These two things are very important, that it should not be a very complicated system. You can make a simple system. First objective is to make a simple usable system which the user which will be user friendly type. So you should minimize the number of screens, use minimum screens which are absolutely necessary. You can meet all the requirements of the customer by using, enhancements, creating new screens, etc. But that will not serve your purpose. Ultimately, if it is very complicated, then you can use enhancement to simplify the screen. Suppose there are 4 or 5 tabs or 4 or 5 navigations that you are making, which mostly happens in SAP. So instead of that, if they suggest, you can bring everything to a single screen data entry. So sometimes that helps. During the business blueprint workshop conducted, your steering committee members, IT departments, and other stakeholders like the production heads or the quality heads or other integration like or finance teams, they will also be present. So you should be having a good integration knowledge also, because there will be questions asked on that, and you should be prepared to answer. And for that, you can also bring your other consultants into that discussion. On premises, let us see what is there in that. SAP best practice for S4HANA. So you click on that. So you have all these areas in which you have the best practice documents. So in our case, it is manufacturing. So you can go to manufacturing, and under manufacturing, you will have manufacturing operations, production engineering. I thought of including this part, but time permit also. Production planning, then quality management. So if you click any of these are the best practice. These are analytics. Now, engineer to order, inbound storage tank management. These are templates, sample process in a process manufacturing. What happens generally? Now, make to order, make to order. There are another two. There are two. One is for process. Then you have SFG make to order. Then make to order with sales and VC. Then we have the make to stock, discrete manufacturing, process manufacturing with silo materials, predictive analytics model. This is new. Now this is again, I wanted to include production, operation, manufacturing, execution, POE. Subcontracting is there. So what there is it MRP area. There is the subcontracting new special procurement key has come up na, to 45. Like subcontracting, stock transfer, consignment, these are the things that we have mainly. And then production in alternative plant, procurement from alternative plant, direct production. So there is a special procurement key 45, which cannot be copied. Other special procurement keys, you must have seen that it can be copied from standard and you can change the values there. But here, this 45 is hard-coded in the program. It is basically a stock transfer from MRP area to plant. What happens in subcontracting is that we have a net segment and a subcon segment. in the standard in ECC. And first it gets replenished from the subcon segment, and then it gets transferred from, right, there is no stock in the subcon segment, it gets transferred from the net to subcon through MIGO or ME2O, and then again we replenish. But in case of MRP area subcontracting, there is a separate MRP area that is set up for by creating subcontractors MRP area and assigned to the material master in MRP area segment in MRP4 view. And then MRP4 or in storage location MRP is in MRP4. In S4HANA, you will not find this. MRP4 storage location view is not there. So MRP area, we have to just assign to the material master. And in the planning, there is a separate planning for each subcontracting MRP area. So material master record creation. This we know already. There is no change in S4HANA. How we create? MM11 is create general plan for future. Normally we use MM01 and special material type. So when we create the material, we have to put the material type. Suppose you have to create a new material type for certain reasons. So what is a material type? Why do we have to do? Because this is important. When we create the materials, mainly for production, what are the different material types that we create or we use? We use the FERT part, then HALB for semi-finish, raw material, ROH, operating supply, packaging material for handling unit management. Any other material types that we are using? Are you using? Achha, there are two more transactions like MM17. These can be used for creating or doing mass change. This is basically a mass change functions of material master. And extension of views is MM50, but MM01 we can use also using the same material code to extend it to other plants. Now, as I was telling that MRP profile we can use. We can create an MRP profile and enter it at the time of creation of the material master, so that the data, MRP related data are copied into the material master, like MRP type, MRP group, and other things. MRP group is a field which is very important in the material master because MRP related settings are there in the MRP plant parameters, overall plant parameter maintenance. But there are some other settings which may be applicable to certain material groups which are different from the overall plant parameters that we maintain in the MRP group. So these two transactions in SPRO, that is OPP Q and OPPR for plant parameter and MRP group are important. We'll check these settings. We can create. So MRP profile, as I have told you, will allow me to maintain default values. When we enter that, it will be copied to the material master MRP views. There is also a forecast profile. How the material master can be extended using MM01 or for a particular material, certain views are missing. We can just enter in MM50 and then enter the material type and select the views which needs to be extended. That we can do. These are the maintenance statuses. We can, these are standard statuses which are available. MRP is D and production is F. Production is A. How you change the material type, that we have already told. OMS2 is the transaction where you create a new material type. Changing a material type, what are the update facilities that are possible in material master? MM02 is the change, manual changes that we do. MM12 is a transaction which we can plan. Normally we don't use. CC04 product structure browser, which gives us all the details of the material. I mean, where it is used, in which BOM, which routing. It is the product structure. And MM17 that we have mass maintenance, we have already told. We have to just select which view we want to update, like say MRC, some plant view. Maybe certain fields which we like MRP type and say, but problem is we can only change a fixed value. Say in These 4 materials or 3 materials will change the MRP type and scheduling margin key. So these materials will select and will put the values to the fields and then execute.
Alright, let's test your knowledge. Here is a question for you. Which of the following is the deployment option for SAP S4HANA? Option A, On-Premise Edition. Option B, Private Cloud Edition. Option C, Public Cloud Edition. And option D, all of the above. Take a moment to think, and when you're ready, choose the correct option. And remember, each choice holds a key to unlocking the answer. Good luck and type the correct answer in the comment section. Course Introduction. Course page. Hello everyone. I wanted to provide a brief overview of ZaranTech's training program for SAP Manufacturing on S4HANA. This comprehensive course covers key concepts and tools you need to optimize production planning, execution, and monitoring using SAP Manufacturing on the S4HANA. Over the past few years, hundreds of professionals have leveraged ZaranTech's SAP Manufacturing on S4HANA course to expand their production management skills and advance their careers. After completing the training, many have graciously shared their success stories on ZaranTech's testimonial platform. In just a few weeks, you can learn how to configure bills of material, schedule production runs, track inventory, analyze capacity, and connect supply chain data in S4HANA. This can open doors to new manufacturing roles or help you deliver more value in your current position. If you want to learn more about SAP Manufacturing on S4HANA with ZaranTech, visit the link below of the course details. Getting started now with the training is a smart investment for anyone looking to boost their expertise in SAP state-of-the-art manufacturing solutions. Thank you for listening.
Some practical session on the system, that is apply lead time scheduling and material master update. So this is basically a routing functionality where we do the scheduling for a routing, and then we see whether the lot size dependent times are updated in the material master. If we go to the, we were discussing material type yesterday, what are the influences that it has. Suppose we select the standard FERT material type. In the details, what are the things that are there? Field reference, that talks about the fields which are available in the material master, and this field reference has certain screen groups. These screen groups, each screen group and screen number has some fields which we can maintain. I mean, the attribute of the fields, like display or say ready for input, or we can hide the field. These things we can do with this field reference. Normally this is not done. I mean, mostly we are not changing any field, but sometimes it may be necessary depending on the customer requirement. The views that we select here will be available for creation or change in default. So I mean, if certain views are not selected, like in this case the PRT view is not selected, that means these views will not be available. This view, production resource tool, all other views, production related view like work scheduling and the MRP, the one tab for work scheduling and 4 MRP tabs, 1 to 4, 2 accounting tabs. Then there is a classification data, costing 1 and 2 for cost estimate run and maintaining the costing parameters for doing the run. Then the basic data 1 and 2, storage 1, 2, storage location, plant data for storage. Then quality management view for assigning the inspection related data, inspection type and other controlling parameters for quality inspection. Warehouse management 1 and 2, sales 3 views, and plant stock storage location. So these are the views that will come up. So if I just so normal practice is that, and another point, that is for this material type we have to mention the quantity and value updation in the valuation area. So valuation area is defined as plant. So in the each valuation area, depending on the material type, we can just for let us say for this finished goods, for all valuation areas, we can see that both quantity and value updation happens. If we go to another material type, let us say in lag, non-stock item, or in BW, non-valuated. So here, value and quantity updation is not there, because this is a non-stock material. So value and quantity updation fields are not ticked. So suppose we have to create a new material type. So standard procedure is we just copy the standard and then make necessary changes, whatever we want to change. So if we have to create a new material type, we will select this one and then copy as. Suppose this is we change the name to and maybe this will not normally all these views are required for finished goods, but let me also select the production resource tool view, and these are the number ranges. A material can have both external as well as internal number range. So when we did in ECC 6 this thing, there is this new field in S4HANA, that is the product type group. This gets copied into your purchase order or purchase requisition. It is basically for service materials, service items. So I mean, if we indicate, if you go to the drop down of this one, if we select service, then it will be treated as a service material. Means basically it is a service. Instead of creating a service master, it will be treated with a material master. And this indicator is copied into your purchase requisition or purchase order for procurement of external service. There are no other changes in S4HANA from the ECC screen here. So normally there are 4 settings here. So basically it is blank. So that means it will be treated as a material. If we put 1, it will be treated as a material. 2 for service. 3, I don't know what subscription is. I have tested with service and material. Maybe, I mean, for material, you do not need to maintain 1 additionally. But I have seen the treatment with 2. So that is changes. Dependent entries means all the entries that we had for, this screen sequence or views and value and quantity updation in different valuation areas, all are copied. So that is how a new material type is created. So going back to the question of DN material type, let's go once more to it and see what is there, whether 2 is selected for DN. So if we go here, it is not there. So in standard, this product type group is not there for DN. But let me see, there is a new service material, a CRV, I think, new material type in HANA. Is it there? Yeah. So in this is a service product. So here you have a product type group of 2. We can have a cycle run with this type of material and see what is the effect of this. This creates a lot of problem, that I can tell. But we can take one cycle with this one. I'm just noting down the cycles that will run subsequently with this. So now we have created a material type for finished product. Similarly, we can create material type for other mainly HALV and raw and operating supplies for production. So this is how the material type is created. No other settings related to the material master from production planning point of view is necessary unless we want to suppress or certain fields. For that, lot of configurations are necessary, because you know that if we work with a standard screen sequence and try to modify that, so all material types which are using that screen sequence will get affected. So that is why, again, a new screen sequence, new screen, you know that all these screens, how these screens are appearing. I mean, that is appearing because define structure of data screen for each screen sequence. Here the standard screen sequences and standard structures are there. So mostly we are using standard industry sequence. This one. And data screens within this one are this. So under each one, say for basic data, we have the subscreens. Each subscreen has a program. So there are certain screens which we have to bring in. We have to look at the documents and find out which program, screen program we have to add here. In that case, that particular screen with the field will come. If you select any and go to view subscreen, then you can see this is the description screen. Means that this program is for the description, and the screen number is this. This is the basic data screen, like work scheduling. If you go to the sub screen, full screen will come like this, and individual there are so many programs under work scheduling. So each section, like 1, 2, 3, 4, 5, 6 sections are there. So each section you can select and see. What I mean to say is that there are certain fields which we can suppress or make mandatory, those things. So those are controlled in this one here. This is the field reference, and material type screen reference is ROH. So for ROH, this is our reference material type, and for for material type FERT, our screen reference is raw, that is assigned in the material type. So we assign this screen reference to the material type. Now, how the screen sequence control, if I go back to the first step, how the screen reference, this industry sequence 21, 14, 15, these are the standard in the sequences. So create program for customized subscreen, this is one. And there is another setting that is done, I'm forgetting that setting, where we go to individual programs or the screens or subscreens, and there we'll have the field list which we can make as mandatory or visible or not visible. Are you aware of that? OMS, what is that transaction?
I think it's in the field selection. If you just scroll down.
S9, what is that one? Yeah, here. So this is the field selection for data screens. Here you will enter the field selection group, and we can get the details of the fields. For field reference FERT, like for FERT it was, and what are the fields? If you click on this one, you will find that these fields, that is basic unit of measure or unit of measurement. So these fields we can make as display or required or optional or hide here. Problem is that Suppose this has two fields, unit of measurement text and base unit of measure. So individually we cannot do, isn't it? So for that again everything has to be recreated. So if I just do a hide here, then both the fields will be hidden. Like in this, we have five fields: material group, name, plant name, no text. This one. If we want to hide the material group, then we go here and hide it. If we hide it here for this field reference, so wherever this field reference is assigned to the material type, those fields will be hidden. So there are five fields. All five fields will be hidden. But how we hide a single field here? So in that case, we have to create a new field reference by copying this one and removing those fields which are not, which we do not want to hide, and keep only one field, and then set these attributes. Let me create a finished good. So we'll go to this transaction. You know this, MM60. Let's take this one, FG129. So we will quickly create a material master record by copying from an existing material. So the views that I am selecting, you see that PRT view is not here because it was not selected for this material type in the material type configuration. So all views will select except these purchase we are not doing for the finished good. Sometimes we do for stock transfer or procurement from alternative plant or subcontracting we do. But quality management, let it be there. WM I am not creating. So I have to put the organization level here. I copy from the same while creating the material master, we can enter the MRP profile. I mean, all data from the, we can create MRP, we can maintain MRP related data in a profile, and that gets copied into this material master. Let me see if anything is there. Nothing is there. So we'll create one MRP profile later on. Just go on selecting it. So everything is getting copied, including the batch number. So classification. I'll delete this class. So all these views are getting created, copying from the standard finished good which is there in the system. Purchasing views we are not creating. Strategy group is 10, so I am changing it to 10. 40 to 10. So if it is 10, then there is no conjunction, right? No conjunction is not there. We'll revisit these views when we do the planning strategy or MRP and demand management. This is the advanced planning tab. So we talked about the advanced planning tab for PPDS integration, but production version is not there because we have not yet created the BOM and routing for this material. So we have to create a production version, which is mandatory in S4HANA. This is the advanced planning tab. So basically it when we set this up, we'll see one advanced planning session. We will indicate this checkbox and do the settings in the advanced planning configurations for transfer of this material, work center, location, plant to PPDS site, then we will be transferring. This will be created automatically. We cannot create these things in embedded S4HANA in the PPDS site. So this will be created as product, resource, and location respectively. For that, this advanced planning indicator has to be selected. And here, in our MRP run in S4HANA side, on PPDS side, we can do this planning run using the planning heuristics. We can maintain the heuristics here, planning heuristics. And we can do the planning run on the PPDS side. So there is one session for that. We'll maintain these things and do. Normally, number 2 is assigned. Let's see. This one. These parameters we'll discuss on that day. Since this is your finished good, so we can assign both 03 and 04 inspection types for in-process inspection, and 04 is for finished goods inspection. That is the final inspection, and it has to be made active. Price control is S for this material type, which is a standard price. This is getting copied from the the material which we are copying. The valuation class is 7920 for account determination. In S4HANA, I think we'll run into problem. Material ledger is mandatory, right? So since the earlier material we are copied from, so material ledger is active. So there are 3 programs we run for this cost estimate for activating and making the material ledger run as productive. So these are already there set up. So that is why this indicator checkbox material active, material ledger active is indicated. Otherwise, it will come as a blank. So we have to run those programs. Let me see. You see that there is a current standard cost estimate. This is basically copied from the material I am copying from. Otherwise, you have to do a cost estimate run, for which the BOM routing production version has to be set up first. Then this CK40N, same procedure as in ECC6 will follow. So that's all. Then we save this material. The material number 2255. When we are copying from an existing material type, the number ranges are also copied. So this is our material. I have created a finished good. Same way, can you please create a semi-finished good and a raw material quickly, so that we can just create a BOM? But one thing before that, let us do 1 or 2 transactions. What is the suppose we want to extend this material view. Almost all views are created, but I think the purchasing view was not created. Let us try this MM50, by which we extend the material view. So our material number, what was the material number? 2255. No? And if we want to, we have to select the maintenance status, which view we are extending to. Purchasing, we say, because purchasing is selected and could have been created, but we deselected, did not create. Later on, if we want to just select the, create the views or extend the views later on, then we can select the view, we want to extend to, and then we can put the plant, because this material could be available in other plants also. We execute. So it comes as E. This is the view we are just trying to extend. Now you go to click on maintain material. So this purchasing appears. You just save it. So now if you go back to your material, you will see that the purchasing view, which we did not create earlier, can be as created, and now it will appear in MM02. So this is one transaction. The other one is through MM01 also. You can just select the views. It will come as deselected, the views that were not created. So if you go here now, you will see the purchasing view are existing now. Let us say the warehouse management view. So with MM01 also we can do. The view that is not created, say for example, work scheduling, warehouse management. So we'll put a plant here. So when we are creating the warehouse management view, we have to put the warehouse numbers here. And a storage type under the warehouse number. Let's say high rack storage. So same effect as MM50. So this way also you can create the views. Extend the views. So basically, other transactions that were mentioned are MM17 for mass changes in material master. So if you do MM17, we can change certain fields. For that, we have to select the material. So let us say that which field, if we want to change any of the data which is plant dependent, so we'll select this MARC table, mark table, and we can go to the field tab where we'll find all the plant dependent fields. So let us say that we'll change the production scheduler profile or plant dependent any other field, maybe MRP group. Say we'll change the purchasing group. So we select this. When we execute, first we have to enter the material for which we are changing. Let us say in our case, our material, and since this is a mass change, let us select another material. Say that FG, what was that from which we copied? FG, what's that material? FG 129. And plant is 1710. Now you execute. So the field that we have selected is purchasing group. So basically we see that in our these materials which we have included here, it does not have any purchasing group. Now we can enter some purchasing group here, new value, say whichever, let us say this one. And then we can test this. It will happen. This updation will happen. So that is we have just tested. Now if we perform mass change, now we save it. So these are updated and we save it. So we'll get a log. So previously, so it has been done successfully. So that is this transaction for mass change. If you open the material now, you will see that the purchasing group is now available. I think it is in MRP. Anyway, we have created a finished good. You can create a raw material, but for raw material, only MRP views will be there. Work scheduling will not be there. Work scheduling view is for production order or process order, right? So for purchase and also raw materials we don't sell, so sales views will not be there as well. So whenever you are creating a raw material, these views will not appear to be created. MRPs and basic data 1-2 classification, this we can create. So please create one raw material and another help. I mean, you can just create one help, I mean, some people can create a help material, I mean, standard. Or even you can copy the standard HALB and create a new material type like ZALB and a Z raw material like ZOH, and then create with these new material types. I mean, whatever I did now. And just do these transactions and see everything is happening. Let's take 10-15 minutes to create and make this mass stage function, MM50. Then what else? These two we have done. And also you can change the material type. Transaction is MMAM. 1710 is the company code. And against that company code, you have to check the controlling area, because profit center is maintained at controlling area level. So for 1710, let me see what is the controlling area. I think it is A000. So we have created the material. Now, so currently we can have material class and batch management indicator. We have not entered in the material master, I think. So if the material is to be batch managed, then we have to indicate that checkbox. Maybe in purchasing or MRP in work scheduling or sales, anywhere one we have to select that this material will be subject to batch management, and we have to enter a batch class. So batches created for this material will be assigned the values of the characteristics which we maintain in that class. So right now we can assign. So you see that material master is an object where we can assign multiple types of classes, class type 001, 0, 2, 3. So there is a configuration in classification system. I'm just showing you how this is possible. So classification system is under cross application component. If you go to the class, you will find maintain object types and class types. So our object type for material is Mara. And you can see all the class types which are available. These you are seeing in the drop down. 0, 2, 3 is not there, but if you go to MCH1 or MCHA, this is the batch. So here you will find that class type 0, 2, 3 is there. If the material is batch managed, automatically this will be assigned. Class in master record, and these settings you note, multiple classification, multiple objects allowed for batch. That is why you can assign class type 0, 2, 3 to the batch. And if you go to the material master also, I mean here multiple classification is active, multiple objects allowed, object type. Let us go to the object type for Mara. So here also you will find that multiple objects allowed. And for each class type, these settings are there, that multiple classification is active. That means you can enter number of classes. That means 001 you can combine with 0, 2, 3. So if you are to get such requirements, say for example, I'm giving you an example. If you look at the equipment class type, which is 002, there this multiple classification is active, but multiple objects are not allowed. For 002 equipment class, you will find multiple classification is active. Just 1 second. Means you can add a number of classes. Multiple objects allowed, that setting is there in for the object type settings. So that means in material master is such a thing where we can assign a class type 001 or 023 or 300 simultaneously, or within 001 multiple classes you can create for this class type and assign to the material master. These things are possible. So anyway, so if we want to create a classification view, then we can create a characteristic for the material. Let us say C001, CT01 is the transaction. Data type, you can enter a decimal place, you can enter so you have to, for numeric characteristic, number of characters, unit decimal places, unit of measure, these things you have to give. And for characteristics, if you want, you can enter multiple values. I mean, if you think that this length has multiple values which you can assign simultaneously, then this multiple value allowed indicator has to be set. Otherwise, by default, it is a single value. Interval values allowed means you can put a value range. You can put a value range in while assigning the values. When you assign the values, first step is here we are creating the characteristic. Negative value allowed also you can do. If you select entry required, this characteristic value must be maintained. There is a thing called object dependency in variant configuration. This I'll discuss. I'll create some characteristics. So here you can influence the value of the characteristics by just entering some syntax. I mean, the value of one characteristic will be visible or not visible or maintainable, or it will get auto-populated based on certain syntaxes we create in object dependencies. So that characteristic or the characteristic value can have an object dependency, like value of one characteristic will depend on the value of another characteristic. So this type of things are possible with characteristic. And next is there is one additional data tab where the value of the character, this is frequently used in batch classes, right? And for field name, you have to put, I mean, in MCH1, you will have those fields which you want to get populated automatically during the transaction from this MCH1 table. So there you will find that there are many such fields, last GR date or batch number, shelf life, expiration date, batch status, last GR date, all these things. So if you maintain like this, what will happen when this characteristic value, this will get updated during our, say we are doing a goods receipt for this material against a production order and a batch is created. So that goods receipt date, that gets automatically populated for this characteristic in the batch master. And we have created this characteristic. Now next step is to create the class. Our class type for assignment to material master is 001. If it is a batch class, we will put 023. So it is, say, training. We'll just go to the characteristic and put that characteristic here and save the class. So first we create the characteristic, then the class, and final thing is that we assign this class to our material master. So there are two ways we can do that. One is if there are multiple materials where we want to assign this class, this transaction CL24N will help. But in MM02, I'll go, if I had created the classification view, then I can just select the classification and the class that I have just now created will appear here. training class, say. And these characteristics, we are not going to maintain the values of the characteristic here in the material master. I mean, it can be assigned a value automatically, as I have said, if it is a batch class, if this is a batch production, or otherwise we can do that. We can assign some values. Both will see. One is this batch determination and batch production, that we'll see, and another is for class type 300 when we do for variant configuration. There we'll assign some values, say color, length, engine type, talking about automobile. So we can assign different values to some configurable materials. I mean, this is basically a placeholder. I mean, based on the values we maintain for a product which can have a large number of variants, say one product car can have multiple values, engine types, exhaust, many other characters. Each one is a characteristic. And depending on the values that the customer wants, that particular material will be selected, that variant will be selected. Basically, we create a material which is a configurable material. The material type is KMAT. And then we assign our real material to this configurable material by creating a BOM link. We maintain a super BOM and super routing and assign object dependencies, create a configuration profile, and we can test it in a sales order. When that material is entered, system will ask for the values, and based on the values that we provide, the placeholder or the configurable material will be replaced with the actual material. Each actual material will have values for these characteristics. I mean, different variants like red, color, 15cc engine, like that. We'll do one such cycle later on, along with 300 class and 200 class as BOM item. So this is the classification part. There is a classify material master record. So any other thing regarding material master you want to, because there are numerous fields production related in MRP 1 to 4 and work scheduling, that will maintain and change when we run the process and see the effects. So basically now we have created the material masters, and we'll move over to the bill of material functions and features of bill of materials in detail. So this is the disclaimer. Please go through this. I must present. And the agenda is describing the structure of BOM, managing the validity of BOM, managing BOM, changing BOM with ECM, analyzing BOM, and configuring BOMs. If we open a BOM, that will be better in the system. Let us consider the bill of material for this this finished good. So when we create the BOM, for a material BOM, we create it for a material, and we enter a plant and a BOM usage. The BOM usage decides which application area it will be used in. I mean, we can have usage for production, we can have for costing, we can have order BOM, sales BOM, or we can have a universal BOM. We can have a BOM for plant maintenance also. So depending on the usage, the certain indicators for the BOM will be selected and it will be available for usage. And also the plant that we entering, that means this is specific to this plant, this BOM. If we don't enter a plant, then it will be created as a group BOM, and later and that means it is applicable to any plant and we can assign it to any plant. A BOM is identified by BOM number, because when you see the you know the BOM tables, right? If you want to see the link between a BOM and a material, that is linked to a BOM number. So there are basically three important tables. One is the MAST table, which gives you the link to the material to the BOM. So for this material, this is my BOM number that identify unique identification of the BOM, which is basically the combination of this material, plant, usage and alternative. So this BOM number, and there is a this is the link. I mean, if I want to see whatever BOMs are available for which materials, then we go to this link table first. Then the BOM has two parts. The structure is basically, we have two parts. One is the BOM header and the other is the BOM item data. If we click on header, there are few tabs. One, first is the base unit. That means to produce this 100 pieces of material, how many components or how many raw materials or other packaging materials or other materials will be required. That we maintain as individual items in the BOM item overview screen, which each item has a detail screen also with many control indicators. So in the header, the important things are the base unit, that is the quantity of the header that is required to be produced. That means if I create a production order of 1000 pieces, so for every 100 base unit, my component quantity is mentioned in the item. That is, so these three components, one is an SFG, 100 quantity. So 100 into 100. So for 1000, it will be 1000 for the production order component screen when the BOM is exploded. The other important parameter here is the BOM status, whether it is an active status or inactive. Active status means here you can configure that this BOM will be exploded in MRP in planned order. I mean, this is the active status. It has a costing relevancy. It will be relevant for work scheduling. That means it will be exploded in the production order. What is this call is? It is used in collective order or direct production. Then it can be a sales order BOM, which will be used in sales order. So this status actually determines whether the BOM can be used. So there are other statuses like inactive. So none of the functions, if we set the status as inactive, then this BOM will not be, I mean, it is not usable in any of the functionalities. History requirement of BOM will come. If that is the requirement, then we'll have to do, I mean, create, change, or display BOM using the engineering change management by creating a change master record. So these are the important fields. One is the base quantity and one is the BOM status. Since we have not displayed the BOM using any change number, so the change number field is blank. A change number allows us to do a validity to the BOM, date validity. And it also helps us to track the changes. What was the old value of any change that we have made and what is the new value? An object management record that is also created. We have to set the we have to set those, I mean, when we create that change number, then this which objects are applicable, those things we have to mention in the object types allowed. And there are other indicators also in the change master record. When we create that change master record with that change, I mean, the valid from date and valid to date are copied from the change master record. I mean, we can use to many change master records to change a BOM, and when we do that, against that particular change master record, that BOM which is applicable will show up. If we don't enter any change master record, everything will show up. Suppose we have three items which we create a BOM with a change master record, say C1. After that, we change the BOM with another master record C2, where we have two items. So that will show up accordingly when we enter a change master record at the initial screen of BOM create or change, or even the quantity or anything. The other data is the size, dimension. These things are required for the purpose of, say, if it is say motor or any parts, production parts, then these dimensions are important. If it is to be integrated with CAD, then we have to indicate this. This can be linked through DMS or content server, or otherwise we can have an interface which can link this CAD drawing to this material, header material. We can assign a document or drawing to this material by creating a document in the document management system and linking it there. It can be on the front end of our PC, or it can be linked to the content server. So these are the header things, as you can see. So basically a BOM which is identified in MAST table, we have seen that it is identified by the BOM number. Same thing, this data in STKO table, this BOM header data are populated. Now, if I go to the structure of the BOM, back to this, we have this item overview screen where we maintain the individual items which make up this header material. Here we can see that this material, finished good, is made up of a semi-finished good. Whenever, that means it also has its own BOM. So that is indicated by this assembly indicator. And then there is a raw material. At least we have to maintain the item category and the quantity for each material when we are assigning it. Now, in the component, there are many controlling factors. If I go to the item detail, in the basic data, we can see that in the quantity data, this is the quantity. There is a operation scrap percentage, which we can maintain here in BOM item for that item only. There is a component scrap percentage also that we can maintain. Basically, there are three types of scraps which can be planned. One is assembly scrap, and component scrap also we can maintain in the material master. Then it will be applicable to all the BOMs of that material. This assembly scrap will increase the assembly quantity, as well as it will increase the component quantities in the production order by that percentage. And if it is maintained in the material master, this component scrap, then it will be applicable to all BOMs of that header. But if we maintain it here, it will have the preference. So first, system will take this percentage and calculate the increase in component quantity from here. The operation scrap percentage is the third one that can be maintained here. That reduces the operation quantity, and that must be accompanied by this net ID indicator. Whenever you are mentioning an operation scrap, you have to indicate this net ID checkbox. And there is another indicator, that is the fixed quantity. That means it will be always fixed. This 100 quantity will always be fixed, irrespective of these variations of scrap and other things. It will be a fixed quantity. I mean, suppose in that case, if we indicate this fixed quantity, so for 100 quantity, we require this 100 piece of raw material. If our production order quantity is 1000, our finished good quantity will be 1000, right? So what will be the quantity if we fix it? This 100 quantity will be fixed. So it will not change. It will not change to 1000, right? There is another portion in the general data. If it is a co-product, then our co-product treatment, that means along with the main component, which is a leading co-product. Suppose it is there in pharma or chemical mostly. When we do a production, some useful product is also created during production. And that is termed as a co-product, which is subject to costing, as well as goods movement also. Another product is there, which is basically a wastage, that is a byproduct. I mean, if you want to treat a co-product in a production order system, then first thing in the material master, there is a co-product indicator that you must select. Secondly, the BOM item quantity has to be entered as a negative quantity. And thirdly, this co-product indicator has to be selected. And then you will do an apportionment structure and create a cost estimate run so that your total cost is divided between your leading co-product and this co-product. I mean, the main product and the co-product. We'll have a cycle for this. Then this is recursion. And in that case, this recursive BOM indicator has to be selected. Recursion must be allowed. And when we do that, this recursive indicator gets selected. Apart from that, there is one alternative item group, this field, where we have a strategy. There are two strategies. One is no check and another is 100% check. And we maintain a usage probability against each strategy. Now, depending on our stock situation and our strategy, several things can happen during MRP run, as well as when the BOM gets exploded in the production order, and also in the reservation. So what will happen is that based on the usage probability maintained, if the stock is there, it will be divided according to the percentage. And if this is a 100% check, if the strategy is like that, so 100% of one material will be allocated if the stock permits, and the other quantity will be 0. We'll have a cycle on this. The alternative group, and there is another one, which is the discontinuation data. In the material master MRP 4 view, there are provision of entering a discontinuation indicator. If it is a discontinued part, means if one material component of a BOM is to be discontinued after a certain time, which is an effective out date, which we maintain in the material master MRP 4 view. These are the three things. One is, suppose this material, suppose this is a component. So this component is to be replaced with a follow-up component after a certain date, which is the effective out date, provided the stock of this original component is exhausted. So after this date, in the planning run, you will see there is a segment, for effective out date. And after that, the original component gets replaced with the new component. But for that, there you have to maintain the discontinuation indicator. There can be two types of discontinuation. One is simple discontinuation, where the discontinuation indicator is 1. That means a certain group of components or a single component will be replaced with a new component after the first component stock is exhausted and after the effective out date. And there is a second one, which is the dependent parallel discontinuation, That means the discontinuation will happen based on the dependency of the original component. We will set up this also and do a cycle, how it is behaving. So that is the setting in the material master, that discontinuation indicator, follow effective out date and the follow-up material. And here in the follow-up material and the material which we have to maintain both the materials, and the discontinuation data, we have to maintain the discontinuation group and the follow-up group. That should have the same group number. So this is basically a discontinuation control, and this is the alternative group control. On the right side, we have some MRP control data. In the BOM, if it is a phantom item, that means if it is not to be, suppose this SFG is a phantom item, then first thing in the material master, we have to do a planning strategy like phantom assembly planning, that is 59. And here, item category, I think it will be 50, and special procurement key will be there. So if it is in that case, it will be treated as a phantom item. So here that phantom item indicator will be there, number one. Secondly, this SFG will not be produced in that case. It will directly explode the lower level raw materials, and this raw material procurement will happen. SFG will then be treated as a logical grouping of the materials. So that phantom item indicator will come then. What is explosion type? You have worked with, suppose, special procurement key, like say direct production, or maybe some phantom assembly planning. Here you can put, and that means when you are maintaining it in the material master for the header, it is applicable to all the items which will be exploded. And suppose we have set it up for a phantom assembly planning, so it will always be a phantom assembly. But if we want to switch off this in particular BOMs, where this will not be treated as a phantom assembly here in this case, then we can switch off from here, and we can configure this, what all are the settings we can switch off, and that we have to assign in the explosion type field. Another special procurement key we can assign at the BOM item level also. So for this SFG, it is to be produced from alternative plant. So we can assign a special procurement key here instead of in the material master of this material. So it will be applicable to this BOM only. So when you see that there is an error in the system is looking for a plant which is not configured in the special procurement type configuration, and you are still having this error, but it is not there in the material master, this special procurement key. You have to go to the BOM and all the BOMs of this header and find out in which item or SFG it is assigned. That is why the error is coming, and then you have to go and reconfigure the special procurement key or remove it from here. So there are many things which are maintained both at material master level, then it gets applicable to all the BOMs, and there are many things which are applicable for this BOM item only, which we must maintain here. The other tab is for the item status control. So when we have an item status indicator, so basically it is coming from the item category. So item category will control whether there is a costing relevancy, whether it is production relevant or plant maintenance relevant or a design BOM. And another setting is the material provision indicator. It is used in subcontracting. So in what happens is that when when we procure the finished good from the vendor, we supply the raw materials to the vendor in a straightforward, simple subcontracting, which is known as a subcontracting type 1. So in that case, our production order will have a subcontracting key for external procurement, control key, say PP02, and we select the subcontracting indicator so that a subcon PR is created, converted to subcon PO, and we have the material. So when we do that GR 541, we have to transfer to SC stock, and then it is issued to the vendor to 543-101. 101 FG is returned, 543, it gets issued to the vendor. So that is the standard process. We have seen this, actually this MPS indicator controls many things, mainly related to maintenance or subcontracted maintenance or repair of parts. So, I mean, we can have K and L, that is material provided by customer. If we maintain it here, then it goes to the vendor from my stock. Now, if it is by the vendor, then this material has to be supplied by the vendor. I mean, the raw material is also he is supplying. So it is not going from my stock. There are two other indicators like rework material and rework material from subcontractor. That means we give a material to the vendor, after rework he returns the same material. That means the material code is not changing. So when you do the GR, you get back the same material. So how to identify the difference, that we treat with a serial number management. And another situation is that this is frequently used, like we are doing a plate cutting, which we cannot do in our factory. Send it to the vendor for subcontracting external agency, and they will return you the plate after cutting the slots, and it will have the same material number. Another one is the rework material from subcontractor, where we will get the return material with a new material number in the stock. So these are the possibilities. This is basically controlled by configuration table T417 material provision indicator, and it is mostly used in AD. I mean, SAP's AD solution, aerospace defense. So these are the different fields which are important. Maintaining and not maintaining these fields, we will create BOM, maintain and check these fields when we run the process and see the effects of these things. So what are the different item categories that are available in BOM? We know about L and N. L means stock item, that is maintained in stock normally. So when it production planned order is created, a dependent requirement is created, which is converted to a dependent reservation when we create the production order. That means when the order is released for stock item, a reservation is created and it is to be issued from the stock. The next item that is there is a non-stock item. Non-stock items are those which are having material code, but they are not kept in stock normally. If we put an item category as N, then this will not be, I mean, a reservation will not be created, because normally we do not keep it in stock. So what happens is that there will be an external procurement that will get triggered, and a purchase requisition will be created for procuring this item when we release a production order. Apart from that, there are other type of items which are also available, item category, like say class item. This will deal with in variant configuration. The class type is 200, where you have to maintain characteristic class, object dependency, configuration profile, and item category K will have a resultant item category L, which must be L. These will set up and do. These are special cases of BOM. Then we have a variable size item. So the advantage is that here one item can have multiple sizes. Here we are maintaining some 100 pieces like that. but this can be a cut piece for this material, which will be used in this particular BOM. So in that case, without having to create another material code, we can enter a formula and we can calculate the dimension, and the quantity will be recalculated based on the formula. So using the same material code, we can use different cut pieces for the raw material as per requirement. So this formula it can be of a volume or a surface area or certain percentage of length or any other dimension. Thing is that the base unit of measure and all other units from which the formula is calculating the quantity, that must be maintained in material master. If it is not maintained as a base unit of measure, then it must be maintained, and the conversion factor must be maintained in the alternate unit of measure data of the material master. So basically, it has mainly the control data, general data, and item data, and how the alternative determination takes place in BOM. In the control data, most important is the modification parameters. So what are the things that are maintained here? One is engineering change management is active. If we don't do this checkbox, then this ECM or the change number management with BOM, create change display, this cannot happen. So we must be having the BOM validity maintenance and EC management active. Other important parameters are the default parameters. Unit of measure is coming as default as piece, and there is one there is another entry for the. Can we control the item numbers here? No. What is this loaded? We don't use this. If we create a BOM with today's date validity, so if we want to say created a previous date, so it should allow. If we check this box, we'll have to check this one. We don't do any settings here except for this EC management active. What are additional control data? Default value are the this size unit. When we use the variable size items, this is the default that is coming for variable size, but that we have to remove, otherwise it will give error. Always it will take this size, which may not be there in the material master. And variable size item unit, that is piece, that we can remove, but the size unit we have to remove. This is the unit which comes as default when you suppose create a area, a small cut having a length and width dimension. So that dimension will come as mm always, but it may not be the base unit of measure in the material master. So let us remove this one. The base quantity by default is coming as 1 if you don't maintain anything. And BOM status is active by default, which you can change in the header. Other settings are in general data. We have already discussed about the BOM usage, and against this usage, we can have these controls. One is mandatory, one is required entry, optional entry, and no entry. That means whether a material master record must be entered for a BOM usage, and it can be used or not. That means for production, our usage is 1 and it is a required entry. It must be, the material must be entered, material code must be present for this usage. and it is relevant for production. When we go to the item data, when we go to the item statuses, we have seen that checkboxes, what relevancies are there. So for BOM usage 1, our costing relevancy is having an optional entry. If I go to the BOM, now it is showing error. Now we have done some configuration and it is showing error. What changes I have made? We have not made any changes here. Only change I have made here. This is not going to affect us. Okay, that default I have to maintain. Otherwise, it will not work. But that instead of I'll make it this. We can override that. Let me see. So that default cannot be left blank. We have to maintain something. So although it is an unit of variable size, so basically in that case we have to do it, maintain it in the material master as an alternative unit. Let us say I have a BOM. Let us enter a variable size unit here. Suppose I have a raw material here with my item category as variable size R. I enter 10 piece of this material. It takes me here. So I enter a size of 10 length and 10 width, and I use a formula for this perimeter of a rectangular cut. So the formula will get executed. So 2 into 10 plus 2 into 10, this will be the size here according to this formula. Now, if the same raw material is used and we need a cut of say some other dimension, we can use different formula for that. So that means maintaining the same material component, we can have different quantities as required without having to change the quantity. If I save the BOM and if I open the BOM again, in the detail screen, I will see, no, not in this material I have changed. In which material BOM I have changed? Maybe in the SFG. No. I can find out via CS15. Our raw material was, this is the BOM where use list, where I can find out where this material is used. SG22. No, I think it was not saved. Here. It is used, but not as variable item. No, not as variable item. We can create a change number and see whether the object management record is there. This is, I think, the lab. There is a lab. What is this one? This is a exercise. Lab activity. So it is saying set the status application use of a BOM and define default value for a user.
Alright, let's test your knowledge. And here is the question for you. Which SAP S4HANA innovations enables real-time inventory, visibility and stimulation? Option A, Embedded Analytics. Option B, Demand-Driven MRP. Option C, Subcontracting. And option D, Production Orders. Take a moment to think, and when you're ready, choose the correct option. And remember, each choice holds a key to unlocking the answer. Good luck, and type the correct answer in the comment section. Course Introduction. Course page. Hello everyone. I wanted to provide a brief overview of ZaranTech's training program for SAP manufacturing on S4HANA. This comprehensive course covers key concepts and tools you need to optimize production planning, execution, and monitoring using SAP manufacturing on the S4HANA. Over the past few years, hundreds of professionals have leveraged ZaranTech's SAP manufacturing on S4HANA course to expand their production management skills and advance their careers. After completing the training, many have graciously shared their success stories on ZaranTech's testimonial platform. In just a few weeks, you can learn how to configure bills of material, schedule production runs, track inventory, analyze capacity, and connect supply chain data in S4HANA. This can open doors to new manufacturing roles or help you deliver more value in your current position. If you want to learn more about SAP manufacturing on S4HANA with ZaranTech, visit the link below of the course details. Getting started now with the training is a smart investment for anyone looking to boost their expertise in SAP state-of-the-art manufacturing solutions. Thank you for listening.
And MD01 classic MRP screen on the right. Left side is MD01N, which is the MRP Live. Now, we'll discuss the features, and there are certain things which are newly introduced for performance and technical considerations, because the tables are simplified and new tables have been introduced. So that is why, based on that consideration and simplification items that we'll discuss, there has been a lot of changes here. And also the restrictions are there. I mean, previously the things that which we could do with MD01, certain things are not available now. And also there are some ways or provisions have been made through some correction notes and manual adjustments, where we can make certain things which are with the client who are already on ECC 6 and want to migrate to S4HANA, and at the same time keep that feature available in S4HANA. For that, we have some adjustments. Very important thing is the custom code remediation or the corrections, and you must know that all classic bodies which are available and used in MRP run in MD01 will not work with MD01N, because these are not supporting classic bodies, but they are replaced with above managed database procedures, MDP bodies. So let us go one by one, the features. So first thing that when we do the MRP run, we can see that we can run for a range of plants. I mean, the scope of planning is not there in MRP Live. In MD01, for planning multiple plants, we have to create a scope of planning and assign it here. But in case of MRP Live, it is automatically adjusted. You can give a range of plants and it will follow the sequence. So the scope of planning is not there. It actually MRP Live will plan all plants in all MRP areas. When we set up this MD01N, MRP procedure, your actually in MRP, classic MRP, first we run that program to make sure that a planning file entries are made. That is, your MDBM table is updated with the materials, with the relevant indicators, like this processing key, create purchase requisition, schedule lines, create MRP list and planning mode, along with the low level code. We have the entries for the materials in the planning file. Otherwise, MRP run will not happen. In case of, so to ensure that, we run a program to activate. After activating MRP in a plant, we have to run this program and make sure that the entries are there in the planning file. But later on, if we want to do MRP area planning, we have to again run another program to take these entries from which are there in MDBM to the DVBM table. So that but in MRP live, this is always available, because whenever, it is based on MRP area only. So this MDBM and DVBM table, which you can see in your MRP, classic MRP, is now replaced with this table. This table, PPH DVBM. So scope of planning is not necessary here. Another point is the creation indicator. We have the creation indicator for external procurement. We have the purchase requisition or planned orders in classic MRP. In MRP live, we don't have the planned orders creation anymore. For simplification of the process, there is a relevant simplification item for that. We don't create planned orders directly. It is purchase requisition, which is always created, and for schedule lines, which is always created for external procurement. And another point is that along with that, when you use planning mode 1, previously what used to happen is that when we do MD03, suppose there is an old quantity and date for an external procurement, requirement. So based on that, some old purchase requisitions are there. Now, when you run MD03 for that material with a new requirement where the date or quantity has changed, your purchase requisition will get deleted and a new requisition will not get deleted. The same requisition will be adjusted with the quantity. But in case of MRP live, always the old purchase requisition gets deleted and a new one is created with the new quantity. Actually, the new MRP run, let us discuss on these points first. Second is the MRP list. Suppose you are doing a planning run in MD01N, and after that in MD05, you want to see the MRP list. It will not happen, because MRP list is no longer supported in S4HANA. Actually, the recommendation is to use MD04 only. MD05 is no longer supported. Suppose I run for a material. Why it is saying a planning file entry is not made is that the planning file, it was run before, and when we run an MRP in S4HANA also, the planning file entry indicators are reset. Now, after the run, if we try to take the MRP list in S4HANA, we'll see that it will give some message like MRP list does not exist because it is not getting created. No MRP list. So SAP is saying that you have to work with MD04 only. Now, suppose, how do you, in that case, suppose you have some procurement, which are procurements which are created, say, for example, I was discussing regarding this purchase requisition element that is created um, in classic MRP. Now we have migrated to S4HANA, but there in ECC you have the planned orders. Now, if you want to have this facility in S4HANA, like you want the old planned orders to be still getting generated in S4HANA after migration, because for external procurement and to convert to PR like earlier. So how do you do that? So for that, they have recommended a body. So you can use that body, that is PPH MRP sourcing body. There are a lot of new bodies that are there. I'll give the list of these and the relevant tables which have got changed. So this new body will allow us to change the procurement element type or requirement type and a type of the element, MRP element. If you have to implement that body. So if you have to keep the existing same, I mean, like in the ECC, if the client wants, then we have to implement this body. But please note that these bodies again an AMDP body. These are not ABAP codes, but these are actually ABAP managed, but these are database procedures. So during conversion pre-check, we have to do these checkings. I mean, on the custom codes. Like for say example, there are two materials. One material is set up which supports MD01N. The other material will have to be planned in MD01. Actually, MRP Live will look at materials which are supported for MD01N. So there is a setup also for that. We can run this program to check the setup for this and find out which materials cannot be planned with S4HANA and which has to be switched to classic MRP. It does so automatically. I mean, whatever materials which are not applicable for running in MD01N, right now I don't get a list for this material, but let me remove the material. So this report you have to run. So this is the material that MRP type is not relevant for MRP. Let us go to this material. Why this MRP type is not supported? Planning procedure. Let me see what issue category is planning procedure. So if I go to the advanced planning, there is some planning procedure setup must be. So it will have to be planned through not relevant for planning. This is in the advanced planning setup. So this cannot be planned with MD01N. So that is why this material will not be planned through MD01N, but when we run MD01N, automatically those materials which cannot be handled by MRP Live will get switched over to MD01. Or if there is any problem, we have a report to Force MRP Classic, PPH Force MRP Classic. I think it is there. No, there is a body for that. That will force, that is what I was discussing. So that body will force, in case it is not taken up by MD01, there is a body implementation which will force these materials, whichever we want to plan through MD01 in, to be planned through classic MRP. So that, because this happens, because you have so many enhancements which are available, and none of these are getting supported in S4HANA. So you have to take this help. Like for example, suppose you have purchase requisitions getting generated from MD01, and we have an enhancement for triggering the workflow for when these purchase requisitions are generated. I have checked that if we use the classic body, it will support in MD023, but not in MD01N. MD0123 this will support because this is in classic, but in MRP live it will not support. So we have to take that above managed body, and there is a body for that. All the list of above managed bodies are there in those simplification items and related notes. So I hope the material that they will provide will contain the list of all such. Otherwise, I can provide the list. The above managed bodies which were previously working and need to be adjusted are in the area of subcontracting, reading a material receipt requirement, then scheduling of stock transfer requirement. As I've told you, the user defined MRP element. If we had to change the MRP element type from purchase requisition to planned order, PIR related, planning parameter related change, MRP list change, all these were classic bodies were available. Now they have been replaced with the PPH set of bodies or spots with the methods. I mean, we have the list of all these bodies which we must consider this, because lot of these enhancements are already there. We have to consider this because we have to make a lot of adjustments mainly in the custom code. So this is basically equivalent is of our MD01N. This we are setting up with a variant as a background job. When we set the variant, we'll get these values. So there are some changes because creation indicators are not there. Another thing that you need to observe is that planning file. You see that this net change planning in planning horizon. In S4HANA, there is no planning horizon. All materials are planned because we are already having optimized database procedures. Everything is running. I mean, reading of the data and the calculation of MRP, generating the procurement proposal, that is not being fetched into your application server and it is running on the database. So time is faster anyway. So even if we consider all materials, there will not be performance issues. But in MRP, classic MRP, we have performance issues because of this not having a live run on the database. So that is why this net change planning in planning horizon was there, and we had to maintain the planning horizon. It is no longer there in S4HANA. If you look at this table now, previous table, MDBM, DBBM table, you will find that net change planning in planning indicator. But now in S4HANA, this table, this is the table for MRP area, which is, and planning file entries in MRP area, which is already set up. You don't have to have told you, you don't have to do. So you see, that's only this indicator is there. Whereas in DBBM table, both the indicators were there. See, this NETPL is no longer there. And now see, in the table level, as we are discussing, previously our MRP header table, that is MDKP. That MDKP table, materials that were not planned, they were saved in the MDKP table with the exception group 8. Exception group 8. Now these are in PPH DBBM table. So MDKP table is not having this data now. Various material master, this MDKP table previously used to have various material master attributes. So in HANA, these attributes are already there in MRC table. So that is why they have dispensed with this MDKP. I mean, further data are not getting populated here based on MRP runs. I mean, whatever fields which are already available in MRC are not coming here. But actually some normalizations happen and adjustments. In ECC6, if you look at the MDKP table, there are more data. MRP list table MDTB is no longer available, but we don't have in that case, how do we find the MRP run relevant details? How do we find that later on if we want? So for that, there is a function module you can try that will give you the relevant details of MRP run, that is MDPX, MDPSX read API. When you have to execute this function module or create a report, and then you will get the MRP run relevant, because you see that the MRP list is not getting generated. Otherwise, SAP's recommendation is that you use the MD04 only, or we can go to the Fiori apps library later, see if there is anything, but there is none for the MRP list. Suppose you have a scenario where the aggregation of dependent requirements based on the sales orders, various sales orders. Now, what happens in normal ECC when you click on a dependent requirement for an aggregation of sales order, you will find that sales order number. But here, I mean, but the aggregation is coming from different sales orders since it's a BOM component. When you create the planned order, you will get a planned order number to which all these dependent requirements are aggregated. When you see that pegging, that you can get when you go to the detailed screen of the ECC6 for that MRP element, that planned order number. But here in S4HANA, no such aggregation happens. So you will not be seeing any planned orders to which it is aggregated. In a planned order field, you will see only a dummy. The planned order number will be replaced with a dummy. Next is the planning horizon. We have already told that the planning horizon is no longer available. S4HANA is actually covers all material demands. It is not limited to the planning horizon. Planning inside the planning horizon is no longer available, because we have told that already there is performance improvement. So by including the planning horizon to restrict our materials during our planning, I mean that net change planning in planning horizon indicator is no longer there. So that this additional effort of maintaining this planning horizon table, that is not there anymore. But suppose you want to include your own logic while creating this planning run. There is a BAPI for that, where you include your own logic. That is the BAPI. You have to implement, you have to use this BAPI for including those additional fields. If I test this BAPI, the parameters, you can see material plant, MRP area, planning scenario. So all these you can planning parameters. Here you can maintain the planning parameters. So here, if you look at the planning parameter, here you will find that you can use, I mean, already suppose this BAPI you are using in some custom code where you have the net change planning in planning horizon. Or when you convert to S4HANA, you must remove that, because otherwise it will not support. Whatever I am telling you is now is the mandatory things we must check while doing the migration from the planning perspective. But there are some enhancements which you may have to use. I was talking about a case where we have an old purchase requisition number got generated, and it is always deleted in S4HANA, and a new number is generated when we are adjusting or changing the requirement quantity or date. But if such thing but in classic MRP, this is already retaining the old numbers. So while converting, if the client requirement is such that they want the old numbers to be retained, and make the adjustments there only, which is not there in the which is not there in S4HANA, then we have to use a body. This is important. So this new body is PPH MRP reuse body. This will retain your old PR numbers and just adjust the quantities. Achha, one more thing that I'll tell you, let me go to that MD01 screen. This one, this indicator. Now suppose you are running MD01. In MD01, you will have this also plan unchanged components. In classic MRP, it is there. But in case of S4HANA, if you want to also include the unchanged BOMs in your planning run in MD02, when you are running in S4HANA, you have to ensure certain things. Like you have to check that this configuration is complete. Otherwise, it will only plan the change items. Here it has to be always set as E. It is already set up here. Enable BOM validity calculation. This is another requirement is there for that one. I'll tell you. And another setting that you have to make. This one is required for making BOM changes with engineering change numbers. When you do that and do the planning run in S4HANA, you have to make this setting, ensure that this setting is there. And another report you have to run and adjust some text elements. That is your PPH MRP start report. When you run that MRP live, you go to the text element and you have to indicate this checkbox. You go to this selection text for making change, for including BOMs which are not changed. Also include unchanged BOMs. This indicator must be set. So these text elements under this our MRP lab parameters, this has to be checked. This is a manual activity. So after I was talking about this engineering change number. So when we change a BOM with the change number, the valid to date from the change number is not copied in STPO or STKO table in case of S4HANA. So we have to make that. So for that, we have to run a report. Otherwise, this valid to date is not taken. And if it is not taken, then this will not be included. These BOMs will not be included, these materials, in the planning run. So we have to run a report. First thing is that configuration I showed you for the BOM explosion, that has to be set as E as enable BOM validity calculation. And secondly, there is a report, CS BOM valid 2, this one. This we have to execute. This has to be actually executed in background for both first with STPO and then STKO. And these are parameters, values. Where from we will get these values? You will get these values from your performance log of previous runs. I'll check how this is found. It is there somewhere. I have kept it. I'll show you. You will have to use these values. And this has to be run in a background. You will have to set up 2 variants for STPO and then STKO. Once you run this, then in the STKO and STPO table, this valid to date will be copied from the change number and you will be able to include this in MD01N. Acha, in S4HANA, regarding the performances, you can get details of previous performances of MRP run. Suppose you have run MD01 or a background run MDBT. Then you can get some performance run results of performance log. There are two reports for that in classic MRP. Same reports you can run in S4HANA also, and you get all the details of that performance. I mean, whichever materials have been run or selected, failure, any implementation or enhancements were there. So like one is say for our MD01 or MD01N, these two reports you have to run and see the performance, the statistics of previous run. So you can put a date range, and if you execute, you can enter other parameters also. Actually, this does not have much data. So you will see that last MRP run happened for a plant, and you can get all this. What was the run time? How many bombs were exploded? None, because there are there are failures also. So you can get all the details. What was the processing key? Was there any enhancements? How many bomb explosions whether happened? Which type of scheduling? So all the materials with termination. There are 4 terminations. So this type of performance logs you can have with this report. There is another report. You can run which shows the heat materials. I mean, which materials were selected. That is again hit list. So you'll get all the materials that were planned with the runtime, and I mean this is the performance statistics you can get. Now regarding some technical parameters adjustment for MRP run, MRP live, you have a report where you can check the present settings, technical values of these parameters. So that is so these are the performance statistics which you can maintain. You can adjust these run times. That is the minimum number of materials to be planned, maximum materials to be planned. This is all related to performance. There are so many parameters here. Now, if you want to adjust these parameters, there is an enhancement spot. That is one enhancement spot or body for, again, this is spot. So that is dispatcher body. So that will give you all the past parameters that the system took, this system performance parameters. And based on the performance of the run, you will get the values of those parameters. There is a method, get parameters in that body, dispatch parameter, get dispatch parameters. So that method will contain all these values. So depending on the performance issues, you can adjust those values here in this report. There are so many, I mean, all these parameters. There are so many things, I mean, all these you can adjust. Acha, and another point is this, important point is this one. In MD01, we have this user exit key. In MD01, obviously, we cannot restrict our materials. When we enter plant or scope of planning, all the materials within that plant are included. But if we have to select the materials according to some logic, for that we have to use this user exit key. And this user exit key has a standard exit which we use. Now in such case, what will happen when we migrate to S4HANA? First thing, this user exit is not supported in S4HANA. So first thing is that the in MD01N we are able to include our plant, and we can have a range of materials and plants. So material restriction with that one is possible. Easy way is to that according to our logic, we can have a set of materials which we can upload here, we can create a variant and use those materials only. Because that user exit key is not available now. But there is an enhancement spot, as I am telling you, PP MRP dispatcher. So in that you can make adjustment and include whatever logic you have entered in this user exit to be working with MRP Live when you activate that body. There are some manual corrections and the corresponding note which is available. Let me show you one thing. One client, just 1 second. We have seen the MD01N screen. Now, this is a new MD01N screen that has come up. And that is after implementation of one body where you can see under red. You can also include materials according to your logic, where you can have MRP type wise restriction, MRP group wise restriction, and low level code wise restriction, which you can include in your plan to further improve your performance. Besides that, there are 4 parameters: MIN, HANA, peak size, numerical HANA, numerical above. Now, these parameters, we don't know the meaning as yet. It has come up this January only. This they have provided. I can give you the name of this implementation, and you can try it out with your ABAPR and see. Then we have to test it with these values. All we can see is that further restrictions are possible and flexibility can be brought in. Discuss on the MRP Live transaction with respect to classic MRP. We say that MRP Live is designed to perform large number of materials from the performance issue. It is best understood when we plan a large number of materials. Suppose we run for one material or few materials, then we'll see that we don't see anything. I mean, it is not an improvement. So, improvement in performance of MRP Live compared to classic MRP depends on the MRP features that we are using. Number of materials to be planned, number of materials not to be planned, because those materials which are not getting planned through MRP Live will get switched over to MRP Classic. So in that case, runtime will suffer. And excess of low-level codes which are getting planned. That is why that enhancement has taken place, and we can further filter out based on the low-level code. Regarding the low-level code, we know that MRP Live normally calls only one low-level code for every plant once in its planning run. And that is the optimization. Now, whenever what happens is that the number of low-level codes is created each time there is a change in BOM. It never decreases, but it always increases the number of low-level codes. So over a time and after multiple BOM changes, there will be unnecessary high number of low-level codes. So there is again a report which recalculates the low-level code. Because this is important for the dependent requirement calculation, all these are planned based on the starting from the lowest low-level code. It calculates the low-level code for the materials. It will give a log. Why it is not happening? There is a recursion here. So that is why low level codes could not be determined. You can check this in your system. I mean, the present number of low level codes or new level. So this is always restricted whenever we run the live MRP. In MRP live also, you can calculate this, but all programs are that we do prior to our run. We can just check MRP records. Here, nothing is coming, but this report is to be run for checking the MRP records and correcting the records. I mean, this will what it will do unnecessary low level code creation which could have happened over the years, that can be reduced. So these are all performance improvement things. See, there is a 999 low level code for this material. When this 999 is assigned, regarding the planning file entries, we have already discussed that previously in classic MRP. We have to run reports to first enter the planning file entries prior to MRP run, and secondly, after MRP run has happened, to transfer, create planning file entries for MRP area, we have to run another report. So that updates the MDBM and DBBM tables. But in classic, in MRP, in live MRP, we don't have, and also we have seen that there is this NET CH indicator is there, PL indicator is not there in the planning file for S4HANA. The setup for planning file entry in S4HANA is run through another report. This is the report which we have already seen. PPH setup MRP records. This can be also run in simulation. Now, besides the simulation, we can have another conversion report where these flags, NATCH, REACL, these flags from the old database table DBBM, these are taken to the PPH DBBM table. This depends on the requirement, whether we need to keep these features which were there in the old client and bring it to the S4HANA system. What is this conversion report? That is the conversion report. Conversion of report from old MRP records to new MRP records. Nothing is converted. This does not have enough data. In the client system, we could have seen. This is not running. I mean, means no data is there for conversion from old tables to new tables. So we have already discussed these things. For external procurement or simplified sourcing, there are additional simplification items that we'll discuss tomorrow. What other changes have taken place? We can give a synopsis of that. If we compare different items, say for example, item wise, MRP activation for S4HANA, by default all plants are activated and all MRP, all plants are activated, and MRP area is also set up. But in ERP, what we do, we have to activate the plant and then run the report, set up planning file. I'm doing the synopsis. So processing key, we have seen that NATCH, NUPL, both are available. These two are available in S4HANA. That is regenerative and this. But NATCH is not available. But three are available in ERP, all three. Low-level code in S4HANA, we directly read from the material master. And the low-level code, additional, I have told you that the additional low-level codes get deleted through a report in S4HANA. That I showed you. So in case of ERP, it is taken up from the planning file, that is DBBM. But in S4HANA, that is why it is directly read from the material master, MARA table. Table related, I have told you that the planning file entries are in DBBM table, PPH DBBM table. But for that is why, I mean, in S4, in ERP system, we have so many tables. MDBM is for plant, DBBM is for MRP area. For long-term planning, MDBL, plant, then DBBL, MRP area, individual customer table, that is KDBM. So all these tables are there, but that is replaced with a single table, PPH DBBM. Now there was some point regarding the long-term planning, and there are some transactions, MD50 and MD51, regarding WBS planning. But these are actually available in S4HANA, but we have to do some optimization on that. So I'm gathering some more information. I'm simply, I have to check the things. I mean, how the optimization happens and the relevant SAP notes. These can be used. Normally, if we run as it is, these transactions and also the LTP transactions, MS transactions, these are not optimized as of. So we have to optimize this transaction, and then only this will get supported in S4HANA. We'll be able to run. There are certain restrictions in S4HANA which is applicable, which were available in MRP, previous classic MRP, but now no longer available. So I'll take those details, like for materials with period lot sizing procedure, which say number of period more greater than 1, the results of classic MRP and results of MRP live in S4HANA will differ. In classic MRP, what happens is that the date of the earliest requirement for planned material, that determines the start of the period for grouping of the requirement. But in MRP live, the start of the period is determined by the planning date of MRP run. Start of requirement for classic is your earliest requirement date. That is how you start grouping. Start of requirement is the planning run date for S4HANA. That is the start of period, which we mentioned in the lot sizing procedure configuration. So the requirement grouping in case of S4HANA and in case of classic MRP will vary. So planned orders created will ultimately be different with the quantity and dates. Now second is the number range for planned orders and purchase requisitions which are output from the MRP run. The number ranges are different. In classic MRP, the same number range interval is used, but the sequence in which the numbers are assigned may be different. The planning run itself is not influenced by this. The planning algorithm of classic MRP or MRP live rather makes what I have told at the beginning, makes no use of the planned order of reuse if different dates or quantities are involved, and a new proposal is created, a new number is created. We can prevent that, and how we can prevent that, or we can incorporate these features of MRP Classic that I have already told at the beginning. Acha, I have told you that when we are running MRP live, not all materials can be run in MRP live, and we can set this up and check this, which are not possible in MRP live, and automatically that gets shifted to MRP Classic in the MRP run. But if you want to do a maximum performance, you should avoid these special planning features to your materials as much as possible. I mean, materials having special planning features may be excluded from the MRP live. So what is the alternative way? There is an alternative way through a transaction, that is MD force MRP Classic. That will force materials which are not available for running. You will see that this material was not available for running in MRP live. So if we run this transaction, we will be able to run this in Classic MRP. I mean, that way we can separate out the materials instead of having the system determine these materials and switch to MRP Classic. That will improve the performances. So it is running on MRP Classic. So you get this report and you just execute this, solve this issue. No standard solution available. In that case, we have to use somebody. Actually, this transaction detects the materials which are not suitable for planning or have restrictions in MRP live. So when you run this transaction, it will have the facility of switching it to MRP Classic. This is why we are doing this from the performance perspective, because when we run MRP live and we select all materials, maybe some materials are not suitable for MRP live and they get switched over to MRP Classic run, and that actually reduces the performance. So beforehand, we can run this report to segregate materials having these issues and run them by forcing them to run in MRP Classic. So that will detect the issue and then try to solve the issue. So these materials we can include in MD01, but this case there is a planning procedure, advanced planning sort of things. So that is why it is not running in MRP Classic. Otherwise, it have run in MRP Classic. See, the advanced planning we'll discuss later. Now, there are theory apps also which will detect MRP master data issues. That we'll discuss during theory app, which can be run to see which materials are not suitable for MRP live. Now, what are the restrictions that MRP live detect normally? One is certain things are not supported. Say, for example, the lot sizing procedures, certain lot sizing procedures are not supported. See, period-based or cost-based procedures are there. That's optimum lot sizing procedures with period-based. That is least cost procedure. Like this type of procedures, lot sizing procedures are not supported in S4HANA. Like cost-based procedures, part period, balancing, group reorder, these are not normally used, but these procedures are not supported in S4HANA. Optimum lot sizing procedures are there, not period, optimum. So these are also not supported. Regarding quota arrangement, we have two types of quotas, splitting quota and allocation quota. Splitting quota is not supported in S4HANA. Regarding scheduling agreement, when we set up scheduling agreement in the system, there are two scheduling agreement types. One is having a release documentation, with release documentation, and another is without release documentation. So Only the one having a release documentation will be, when you create the scheduling agreements, you have to be careful. Without release documentations, this will not be supported in S4HANA. So in case of the legacy has scheduling agreements on S4HANA having no release, no release documentation, you have to delete all this and create again with the release documentation type. MRP type, if I go to the material master, there is this MRP type I have never used. Has anyone used seasonal MRP? In forecast, we have used the forecast types, seasonal. But in case of MRP type, I am not aware. But this is not supported, seasonal MRP. So in this case, you have to use classic MRP procedures for this type of materials. However, this demand-driven MRP, that D1 and D2, D1 is for discrete and process, and D2 for replenishment or repetitive manufacturing. This will be used. Restrictions in other areas like stock transfer requisitions were there, but this has improved. And again, those whenever that is not possible, that transaction force MRP classic, that has to be evoked. Lot of things are there. MRP Live will not participate in materials having AD, subcon. That is more of a plant maintenance type of requirement or refurbishment process. Now there is special procurement restrictions also. For direct production, we have to use classic MRP. If we want to use live MRP on direct production, then if we have to first check whether such materials can be set up as a phantom planning. But from later releases, they have now been changed to and I think it is supported now. It is supported from 1909. There are certain other restrictions. Let me see whether this long time dump or system issues related checks are there. So there are tables, and let me see what materials they are providing. Then I can provide you with a comprehensive things. If because whatever has been discussed over the last hour, these are all important things and must be checked. These are all part of the simplification items, and all these steps we must check in the system and adjust. Let us see some of the changes that have taken place in the material master. For procurement, external procurement, there is a field for quota arrangement usage. If the material is to be considered in MRP and if we maintain a quota file, then we have to make it considered in MRP run. So for that, this quota arrangement usage indicator was there previously in MRP2, but here you will not find that. It is no longer used because in classic MRP Live, it is always used quota arrangement. So it is not required to switch internal to a material master. Let us go to MRP4. So this indicator for BOM explosion or dependent requirement, this selection method, that is not there. So certain fields are no longer there. You also can see that there was a segment below for a storage location MRP. I mean, storage location to be separately planned or storage location not to be planned, those were there. But now we don't find it. This entire segment is not there. So storage location MRP is replaced with MRP area planning. So these are the changes in the material master. And advanced planning tab we will discuss in detail when we will be running the advanced planning and when we will be filling up this data. Another field, let us check this field, scheduling margin key. When you do in ECC 6, if you maintain the scheduling margin key, if you don't maintain, then it is not mandatory. But if you maintain, it has become mandatory. But by default, it is not mandatory. In ECC 6, is it mandatory? No. Even if you maintain, it is not mandatory, right? But in S4HANA, it is mandatory if you maintain in configuration. Regarding production version, we know that it has become mandatory because this will be also a part of advanced planning. So unless the production version is maintained and it is transferred as product data structure, PDS, in the PPDS side, so we cannot do the PPDS run without that. So it has become mandatory, and for simplification reason also, sourcing has become easier, even for external procurement. So BOM is determined via production version only. And can we upgrade the data? Upgrade the existing data to have a production version throughout? I mean, whenever there is a change in the BOM. So the latest BOM can be determined via production version. So for that, I think there is a report. So if there is BOM change, so it will take into migration. I mean, when we are selecting the production version, this will migrate. So we have to take care of this one also. So the proposal is to create new production version. So if we select and then execute, your BOMs will be updated in the production version. So this is important because we are only selecting based on the production version. So this is for the BOM provider. BOM changes through change number we have already discussed. What needs to be done? We have to select and then run 2 reports to update the valid to date in the 2 tables, STPO and STKO. Then the change numbers will be effective. So whatever I have told you is each and every report and programs are important while considering the migration. Right now we are not migrating, but I am just telling you which are the simplification items to look at and what are the restrictions. So let me see if I can show you the concept of demand-driven MRP. Actually, this is a thing that I have made earlier in the other projects for a customer POC. So I'm just going through. I'm not sure anybody can share this document. I mean, nobody can, in fact. And so I'll just show it in the screen. So let us go through the concept first. Then while doing the demo in the system, that will be recorded and you will be able to do later on. So the first part is the concept of DDMRP. So if we look at it, our normal PD type of MRP, mostly we have been using in ECC 6 or ERP system, has these 5 steps. We have the bill of material, we have the overhead inventory, we have the scheduled receipts, and we have the critical items, MPS items. So MRP takes into consideration all these things and creates the replenishment proposals or orders and generates exception message. So basically what is happening here is step 1 is the netting of all 4. So net requirement that we calculate is the total stock or the inventory plus our expected receipts and firm receipts and minus the requirements, expected requirements from customer requirements or PIR, depending on the planning strategy. And then employ the lot sizing procedure to generate the lot size. That is the quantity. and then do the time phasing, that is the offset that is required to obtain the below level materials beforehand, and the times, lead times, which is the most important thing. Lead times to determine the below level materials. We do the BOM explosion and generate the gross requirements of any required components in the next level, and we go on the iteration of these steps until all levels are processed. For each level, we do this. So what are the problems that we are facing with this? Problem is the supply chain nervousness and the volatility of the system. Main thing. That is, materials having a long procurement lead time will add to the nervousness because they may not be available before production at the next higher level. So if we look at the factors of factors are supply chain complexity. When it started way back, 50 years back, there was no such complexity. It was low. The product life cycle was long. Customer tolerance was low. Product complexity was low. Product customization was low. Variety of product was low. Long lead time of product was few. Long means why it was few? Because first thing, the product complexity or product variability was low. So less number of products to consider the lead time. So since we were working with less variety and volatility, our forecast accuracy was much better. But all these things have changed in 50 years because the supply chain, due to variable product and different operations, has become highly complex. Life cycle of product, customer tolerance, product complexity, all this has changed. Complexity is high, customer tolerance is low, product variety is high. Now, due to these changes in the supply chain, our long lead time of parts, this is many now. You have to deal with many parts which is having this long lead time. So all these factors, what is the implication of this new normal? The implication is that we have elongated and fragmented while customer tolerance have dropped. That means to reduce the customer, to improve the customer tolerance, we have to ensure, we have to hold these stocks at some strategic point. Now it has become a must. So that means strategic means what? We have to identify materials which are having the long lead times and do a strategic inventory for these materials. So our planning horizon has become further from the actual demand realization. So longer range of forecast has come up. The products having shorter and shorter life cycle or shelf life, and more use of common components. All this means we have to manage stock positions for effective capital and resource management. That means ideal situation is to hold the stocks at all times for materials which are having a long lead time in the supply chain. And for this, it is necessary to have a detailed item level forecasting, and that is very difficult. So with complex planning and supply scenarios than ever, the past is not a good predictor for the future. So the y-axis is the parts which are in SKU. So these are the ranges. So we have an optimal range, which is green. We have a warning thresholds, and too much and too little are the areas which are undesirable. So there is an oscillation. There are two curves. One is an inverted bell-shaped curve. So we see that there is an oscillation between these two limits and the optimal range. This is basically a statistical bimodal distribution of inventory, which is basically making the product oscillate between the ranges, and that means the supply chain is not stable. So effect is persistently high inventory. Second, chronic and frequent shortages. Third is high expedite and waste related expenses. So how much we can have so much inventory and not be able to ship the orders? That is a question. We paid for the last freight, now we don't need it. So that leads to the nervousness of our conventional MRP. So conventional planning, to trigger MRP, conventional planning requires the demand signal. The MRP essentially uses two types of demand. That is, one is the actual, that is maybe from sales order or customer, and another is forecasted, maybe PIR or customer requirement. Use of forecast demand is a choice. So why MRP have to depend on a forecast? MRP is a perfect calculator to balance. So MRP in a forecast is a calculator to balance the requirement with supplies, but it assumes one thing: there is enough time across dependencies. That means we have enough time to produce. That means we assume that the materials for production, raw materials down the line, will be available in time as per the scheduling dates determined by the system. So the total procurement time and cumulative manufacturing time is much greater than sales order visibility horizon. So to compensate, MRP plans forecast demand signal in an attempt to have the right things at right time. We get the forecasted figure from sales and we do a make to stock. But that leads to inaccuracy. So that is what is the nervousness? The characteristic of a MRP system when minor changes in higher level, that is say at the top level or a sub-assembly level, records or the master production schedule, that will cause significant timing or quantity changes at a lower level. That happens with materials having a long lead time down the line for raw materials. So that is why our this planning or forecasting. So what is the present solutions? That is, frequently MRP has to be run and we must have a weekly bucket. But more frequently we run, the system will change. It will adapt to the new situation. So in order to do a damping, MRP is run less frequently. Not every day, maybe there are two MRP runs, maybe. One is monthly and one is having a daily run. Those who are not having this type of demand-driven concept, see, actually, if you ask me, no system is foolproof. We know that DDMRP also is 15 years old and there is a change in the version. And after not fulfilling this, predictive MRP has also come, which I have not employed anywhere. I don't know, but it has also come. Why it has come? Because of certain things which are not made by this one. So this is one of the solution. Another is the flattening of the BOM. That means the number of levels in the BOM, if we can limit the number of connections, how we can do? So that means semi-finished levels are dispensed with, or certain SFG levels are dispensed with and directly going to the raw materials level. Reduce the number of connections. Main point is the right material is not ready at needed time. This complaint we receive from the clients. So this gray area part, that is MRP plans never properly synchronized with all levels. Variability in one level is not immediately reflected in the another level. The supply variability cases delay accumulation across dependent network. And MRP plans are built using dependencies. So these gray areas that leads to this right material is not available at needed time, and these delay across levels accumulates. So the facts are normal and random variations exist in every process. So our this process is still deemed to be at steady state as long as variations are within calculated control limits. That is the warning limits we have seen. But steady state does not mean that there will be no variations. But it will be within the control limits, but the variations will be small. So many components can have good availability, but it only takes one or two serious implications to change that for the parent. So basically an extreme change in the supply position upstream in a supply chain generated by a small change in the demand downstream in the supply chain. So inventory can quickly move from being back ordered to being excess. So this is caused by a serial nature of communicating orders up to the chain with the inherent transportation delays of moving product down the chain. These are all demand-driven MRP concepts introduced by J. Foster in 90. I'm not going to the theory aspect. This part. What SAP has done in the DDMRP, that is more we are interested in. The demand signal distortion flows from final assembly back to the foundry and the supply in the other direction. And if there are more parts in the supply chain, then the situation is worse. These are all theory. I'm not good. So demand-driven MRP is a model. It plans and manages supply chains to protect and promote flow of relevant information and materials. DDMRP uses strategic decoupling points to drive supply order generation and management throughout a supply chain. So DDMRP has 5 components. First is the strategic inventory positioning. That means there has to be a strategic decoupling. When we see a BOM structure and connections, so we calculate the lead time of each of the components as we go along the chain. And components having the highest lead time of procurement are strategically decoupled. Means they will be excluded from the MRP procedure and we'll have a buffer profiles. We have to calculate a buffer level for this. So that is called the strategic inventory position and strategic decoupling. Then we'll have to do a dynamic adjustment, do the planning run and see the width of different zones, the 3 buffer zones. So basically it is earlier we have 2 questions: how much inventory to hold and when to reorder. So in DDMRP, the focus is where in the supply chain or within the company the position. First thing is the positioning. Where in the supply chain or within the company the position of the inventory. What can happen? We can have a reduced total inventory. We can compress the lead time, less disruption, increase overall stability, increase overall agility and protection of performance of critical resources. So once we are able to do a positioning or strategic inventory, after decoupling and we do the buffering. So basically the concept of strategic inventory positioning called a decoupling point that breaks the connection between dependencies. So creating independency. between supply and use of material. Commonly denotes providing inventory between operations so that fluctuations of the production rate of the supply operation do not constrain production or use rates of the next operation. So it does not hamper the production or delay the production when we have a strategic decoupling. The location of the product structure, the decoupling point or distributor where strategic inventory is placed to create dependency, that is called the decoupling point. Decoupling point between sub-assembly and final assembly. We have the foundry, we have the component from foundry, then the sub-assembly is done and final assembly. So where we will put the strategic decoupling point? It will have to be placed somewhere within the supply chain. So we have to consider some factors while doing this strategic inventory positioning. We have to consider customer tolerance time. The customer willing to wait for the delivery of a product. Market potential lead time, the lead time that will allow an increase of price or the capture of additional business through either existing or new customer channels. Demand variability means potential for swings and spikes in demand that could overwhelm resources. Then supply variability, the potential for and severity of disruptions in sources of supply and or specific suppliers. This can also be referred to as supply continuity variability. Inventory leverage and flexibility, the places in the integrated BOM structure or the distribution network that leave a company with the most available options and a base lead time compression to meet the business needs. And critical operation protection is the minimization of disruption passed to critical resources and control points. These factors are to be considered while deciding on the decoupling point. So what are the lead times in supply chain? One is the purchasing lead time. It is the lead time to obtain a purchased item. This is the your planned delivery time, then GR processing time, transportation time, receiving inspection, put away, all these things. So manufacturing lead time, that includes the actual order preparation, preparation time, queue time, wait time, setup time, run time, move time. Then after GR, the inspection time and put away. And the cumulative lead time is the longest planned length of time to accomplish the activity in question. It is found by reviewing the lead time of each of the bill of material part below the item. Whichever path adds to the greatest number defines cumulative lead time. And then comes the ASRLT, which is the actively synchronized replenishment lead time. The longest unprotected or unbuffered sequence in a BOM for a particular parent is called the actively synchronized replenishment lead time. Longest or unprotected, unbuffered time. Let us take this example. One FG, then SFG, further SFG, and raw materials. These are these two lead times that we defined in the last slide, this MLT and CLT, manufacturing lead time and cumulative lead time. These are the extreme measures of lead time. To make MLT a realistic planning input, manufacturing time, all components at lower level would need to be stocked and reliably managed so that they are always readily available. This is the point. There should not be any production, delay, means between the operations. as we move along, the material should always be available. At cumulative lead time, assume that no components on the longest path will be available, making it very unrealistic. We have the manufacturing lead time for the finished good is 2 days. So cumulative lead time for FG is 26 days. In the circle, these are the days. That is the maximum time. We have to go through this chain. You can calculate whether this 2, 7, 3. You can calculate the time. This is 11 days. 15, 3, 18, 22, 27. If we follow the left hand, the first one, this first chain, this is 26 days. 7. The longest time, that is 26 days. That is the blue path. So initially your ASRLT is the last terminology, this one, which we used. Actively synchronized replenishment lead time. So FG initially we find that ASRLT is 26 days, that is the maximum. So maintain some stock of say 501, which has the highest lead time. So that is our decoupling point. So this 11 days become 0. 0 or changed. Now we recalculate. We maintain some stock for RM 501 and we recalculate which is the longest one. Now 7, 4 and 7 and 2. So that makes it 20 days. If we maintain stock of 403, SFG 202, SFG 202, SFG 301 and RM 302, ASRLT becomes further less because these stocks are there. So now the lead time has become this. So we don't have to procure this. RM 302 stocks is also there. So it is only 6 plus 2, 8 days. And we can calculate the stock of ASRLT similar way, considering the stocks. So that means basically we have to decide on a strategic decoupling point to reduce the synchronized lead time. This is the first step of strategic inventory positioning. So we have to create a BOM matrix where we have in the row different columns at the top row all the products having the parents. And to produce these products, the components, we have to write in the items in the different rows and enter the times there, procurement times there. So purpose is to find the decoupling points by comparing BOMs of different parent level items by looking at whether there exists any shared components between these, which can be stopped so that it can affect all the FG productions. So any component in the synchronized lead time path that has to be identified. That is the primary focus for multiple parent items. That is going to give us the greatest benefit and inventory reduction and reduction of lead times. Now, if the parent material is to be stocked, then we have to, our objective is to reduce the inventory. And if it is non-stock, then we have to reduce the lead time. Now, once we decide and identify the decoupling points based on this synchronized lead time calculation, then we have to make decoupling points. That is, we have to create the buffer zone width and we have to define buffer profiles first. To calculate the width of the buffer zones, there are 3 buffer zones that will come to. We have to define the buffer profiles first. It is a group of settings or characteristics which are having the same attributes. Say, for example, item type, lead time, variability. So I am coming to these buffer levels. There are some terminologies here. So stock buffers are sized to a number of factors. So first you can see the 4 buffer zones. The excess zone is above the green zone, which is the OK zone, where we have the sufficient stock. The yellow zone is the zone where we have to rebuild. And red is the base limit, which is the alert zone. And further, another red is there, which is the stock out zone. And below that is the black zone. No stock. Now, objective is to increase the width of the green zone to an optimum level. At the same time, there should not be excess. Or we have to optimize also the width of the yellow zone. So do that, some factors are considered. One is average daily usage or ADU, which is calculated using a rolling past horizon. This ASRLT, that is the active synchronized lead time. Location of the parts for distributed parts. And what is MOQ? MOQ is a factor. The buffers are arranged in 3 color zones, red, yellow, and green. Each zone has a specific purpose and vary in size and proportion depending on the buffer profile. Now, buffer profile has to be calculated. The green zone is the heart of supply order generation process embedded in the green zone is determined by the 3 factors. How does the width of green zone gets calculated? The percentage of ADU over one full is ASRLT, significance of MOQ if applicable, and impose minimum order cycle if applicable. The greatest number determines the size of the green zone. So calculating the green zone as a percentage of ADU over these things which is there in this slide, these are actually calculated in a Fiori app called buffer zone calculation that we'll do in the system. So calculating the green zone as a percentage of ADU over ASRLT requires knowledge of what lead time category of SKU belongs. whether it is a short time, medium time, or long time. The recommended percentages of lead time factors are long lead time 20 to 40% of ADU. Medium is 41 to 60%, and short lead time is 61 to 100%. Average daily usage. It is also called a lead time factor. The longer lead time of the SKU, smaller the lead time factor. And smaller lead time factor means green zone, smaller green zone and frequent ordering. Now in MRP approach, we have large infrequent orders. And in DDMRP approach, we have small frequent orders. That means the width of the green zone should be calculated that way. The DDMRP approach forces as frequent ordering as possible, so width of the green zone should be less. And that means smaller lead time. Let us take an example. Average daily usage is 10 per day. Active synchronized replenishment lead time is 12 days. So from that, we have a lead time factor of 50%. Our lead time category is medium and order cycle is 7 days. MOQ is 50. So step 1, calculate the size of the green zone using lead time factor, which is average daily usage 10 per day multiply by ASRLT, that is the lead time in days, multiply by the time factor, which comes to 60. Step 2, compare calculated green zone against MOQ, which is 50, and that is less than the MAQ lead, we have given as 50, and that is less than the calculated green zone. So that is 60. So we are going with 60. Third step, compare calculated green zone against imposed order cycle. Now, order cycle is 7 days. And average daily usage is 10 days, 10 per day. So order cycle factor is 70. So order cycle factor is more than the green zone. So highest of these three will be the width of the green zone. So our green zone will be 70. And the order frequency, that will be green zone divided by ADU, that comes to 7 days. So that is how between these three we calculate the green zone size. Second, yellow zone is calculated as 100% ADU over ASLRT. ADU was 10, ASLRT 12, and 100% of that is 120. So that is our yellow zone. That is calculated as 120. The red zone is the embedded safety in the buffer. The higher the variability associated with the part or SKU, the larger the red zone will be. So calculating the red zone requires three sequential equations. This is very important, calculation of red zone. So the base of the red zone is average daily usage multiplied by ASRLT into the lead time factor, that is 60. And this lead time factor corresponds to the same range. Short, medium are used for green zone, same, but can have a different actual percentage of what green zone had used. And the red safety is rate calculated as a percentage multiplier of the rate base. So rate base is 60. That is called a variability factor. And for high variability, these factors will be fed into our system to calculate the, and we have to get these factors from the system. We have to calculate from the client requirement, these factors. So variability, this high variability, medium variability, and low variability are defined here. And accordingly, the rate safety will be calculated as a percentage of the rate base. And this variability is measured by what is known as the coefficient of variation. The coefficient of variation is the standard deviation of demand or supply divided by ADU. The coefficient of variation distribution decides whether the part of SKU belongs to high variability or medium variability or low variability. For low variability, the variability factor is generally 33%. So rate safety will be rate base into 0.33, it is 20, and total red zone will be 20 plus 60, that will be 80. So red zone is 80, yellow is 120, and green zone is 70. These are the formula for calculating the zones based on those elements. So first step was identifying the strategic decoupling point. Second is the calculation of the buffer levels and the width of the zones. Now we have to do a dynamic adjustment. So first is recalculated adjustment that can be done into it either by using average daily usage based adjustment or by using zone occurrence based adjustment. Average daily based usage adjustment is the past consumption of stock keeping unit is recalculated by using rolling time horizon. So we have an available stock position against average daily usage. So the recalculated adjustment, zone occurrence based adjustment, their average order interval is defined for a part based on demand and lead time profile. And if the occurrence is not according to the average frequencies and adjustment made for the buffer profiles. Let us see the calculation. And second is a planned adjustment that is based on forecasted ADU. Third is the manual adjustment. This ADU manual adjustment we do in these Fiori apps. So we have the threshold, ADU alert threshold, ADU alert horizon. These terminology, this we'll see. So once we do the adjustments, then comes the next point that the demand-driven MRP run and how the net requirement is calculated. That is, in our MRP calculation, we have the net requirement calculation. So here we have a net flow equation. So our next is what is I am having and what demand do I need to fulfill immediately and what is the future demand. So net flow equation will be on stock hand plus open supply minus qualified demand. Qualified demand is the actual demand or not the forecast demand. Now if net flow is less than top of yellow, a supply order is generated. And the supply order quantity will be top of green minus net flow. So net flow is less equal to top of yellow, then the order is generated and that will be top of green. The quantity minus the net flow. And what is a qualified demand? A qualified sales order demand is the past due sales order, today's due sales order plus spike. Now, what are qualified spikes? So, qualified spikes are demand peaks from customer orders which will be delivered in future. So, we have spike horizons and order spike threshold which have to be defined. So, spike horizon is the order spike horizon, which is equal to the actively synchronized RLT. That is the time horizon for monitoring of future demand of SKU. And threshold is the limit of demand what is allowed to be in the horizon without being qualified as order spike. So order spike threshold will be our red zone into the factor. And this factor is 0.5 generally. So that is our qualified sales order demand. This is past and future where spikes are not considered. So we have to define a spike horizon, and within that spike horizon, we have the order spike threshold, which is the rate base into 0.5. That is the height of the spike horizon. And we have to consider this as qualified orders. So if we consider the bomb explosion in case of MRP and in case of DDMRP, so when a supply order is generated at a higher level, decoupling stops the explosion of bomb at decoupling points. For in case of DDMRP, which we did not have in the MRP explosion. So there is no bomb explosion because of the decoupling point is buffered. We have maintained the stock level after calculating the zones, and accordingly we have maintained. And that is why the final net flow calculation and the order quantity and date, these are calculated based on those equations depending on the buffer zone. The consumption and demand is accumulated at a point until resupply is recommended through the net flow equation. Which point? The decoupling points. The explosion then begins again relative to the parts respective component. The concept is preventing nervousness, because here we assume that at the decoupling points we have the sufficient buffer. So this is basically a decoupled explosion. A distinguishing characteristic of DDMRP system. It is important to understand that there is independence. That means in these decoupling points, that is, the entire supply chain, this procurement cycle, that is independent of the decoupling points. It is delinked.
All right, let's test your knowledge. And here is the question for you. What does DDMRP stands for in SAP S4HANA? Option A, Digital Demand Management Resource Planning. Option B, Demand-Driven Material Requirement Planning. And option C, Distribution Demand Management Resource Planning. Or option D, none of the above. Take a moment to think, and when you're ready, choose the correct option. And remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Course Introduction. Course page. Hello everyone. I wanted to provide a brief overview of ZaranTech's training program for SAP manufacturing on S4HANA. This comprehensive course covers key concepts and tools you need to optimize production planning, execution, and monitoring using SAP manufacturing on the S4HANA. Over the past few years, hundreds of professionals have leveraged ZaranTech's SAP manufacturing on S4HANA course to expand their production management skills and advance their careers. After completing the training, many have graciously shared their success stories on ZaranTech's testimonial platform. In just a few weeks, you can learn how to configure bills of material, schedule production runs, track inventory, analyze capacity, and connect supply chain data in S4HANA. This can open doors to new manufacturing roles or help you deliver more value in your current position. If you want to learn more about SAP manufacturing on S4HANA with ZaranTech, visit the link below of the course details. Getting started now with the training is a smart investment for anyone looking to boost their expertise in SAP state-of-the-art manufacturing solutions. Thank you for listening.
This is the pre-upgrade check or PP MRP. So the recommendation is that you must follow the instructions here or the corrections. I mean, when these pre-checks need to be performed. Moreover, before that, I'll share one ECC system with just the readiness check program has to be run, and you have to, that will give you the items which are not ready or whichever is ready. Just give me a moment. Okay, I'll show later. So connection is there. So in our system, so that is what I mean. I was looking. So all these are pre-gate checks for PP MRP. So if you look at the correction instructions, here you will find that you have to implement this node for pre-check activities for migrating to S4HANA. So this code has to be implemented, and we will today discuss about the storage location MRP. If we look at the ECC system, we know that in MRP 4 view, there is a provision for storage location MRP. That means we can exclude a storage location for MRP run. It happens at plant level all the time, or we can plan it separately. So that means there is an indicator which can be 1 or 2 that will enable this. But I mean, this facility is available in ECC 6. But in S4HANA, this storage location MRP is not available. So the option to plan separately is to to create MRP area, and through MRP area planning we have to do. You also have the MRP area planning activated in ECC. Now in ECC, how do you do this? I mean, first thing is in the first case, if you have this storage location indicator 1 or 2, that means you have planning at storage location level, but in S4HANA, you don't have this support. So in this case, what you have to do, you have to activate this MRP area on the S4HANA side. So main thing is that we know that there are 2 programs or setup programs we run for making the planning file entry at plant level and then MRP area level. This MDVM 20, this program is for setting up your planning file at plant level, and DBVM 20 is then executed if you want to activate or transfer this data from MDVM to DBVM file. That is in ECC. So if you don't have MRP area planning in ECC, you only have this MDVM file, and you can execute storage location MRP. If you want to activate MRP area, then you run the other program, and then it gets transferred from your MDVM to the DBVM file, and this is the first step. And then you do the MRP area related configurations by creating MRP area for plant or storage location or subcontractor as per your requirement. So in case of storage location MRP, you have to set up MRP area with MRP area type 2, define MRP area, and do the MRP area planning. You can maintain this MRP area segment in the material master MRP 1 view. You can enter MRP area specific data there, so planning will happen at the MRP area level and separately for these storage locations. Now in S4HANA, if you try to, first thing is that there is no node for this planning file entry. Planning file entry actually that is what, if you look at the plant table in S4HANA, you see that this flag MRP flag is already set. Actually, there are 2 editions. In the cloud edition, it is set by SAP. So when it is delivered, it is already set. So that is why MRP area is already activated. So you don't have to run first thing, planning file entry is already made. That is not in this DBVM table, but it is, we have seen already that PPH DBVM table. There you will find these entries with this flag set. So MRP area is by default activated. In case of on-premises edition, we have to do the MRP area activation checkbox for the plant level in the MRP area planning, like in ECC. That we have to do. That program is missing, both for MRP area as well as plant level. So you don't have to run those programs. So by default, the only thing is that you have to do the configurations. For MRP area, this thing you still have to do. I mean, setting up the MRP area at, say, plant or storage location level, define MRP area for plant and subcontractor. This part you have to do. And you have to create the MRP areas. Suppose you create one MRP area. This is the thing. So that is what. So in case of storage location MRP, how suppose we have storage location MRP in ECC. Now we have to do MRP area planning in S4HANA since storage location MRP is not available. So what we will do? First thing I told you that we are when we are doing the check, there is a routine here in this correction instruction. There is a routine here. You will see they check the MARD entry for 1 or 2 here. Now, if it is either 1 or 2, then this remediation, this correction note we have to implement. So that means we have to activate this MRP area planning, set up this MRP area planning in S4HANA side. We have to, it is already there, but we have to create those MRP areas and assign to material master. And secondly, already since this data are already there on the ECC side for storage location MRP, this indicate as 1 or 2. So this has to be taken care of in the MRP area side. So that is why a conversion program we have to run, which will convert and it will correct the data on the HANA side. This MRP area storage location migration. I mean, those storage locations where we have this storage location MRP will be converted for MRP area planning. You have to execute this report, MRP area storage location migration. Suppose you look at the result, I have given some dependent requirements I have created. Look at the result at the overall plant level, where MRP area is equal to plant for this material. Then I have a requirement and a purchase requisition is generated. Since this is not excluded from planning for at the plant level. But if I look at the MRP area level, which was for which already, also this MRP run happens, it will include, since in S4HANA, the scope of planning is not necessary, it does everything. All the storage location, if MRP area is set up, it is always run at MRP area level. So here you will see that it is not planned. So it is excluded. You can set up one MRP area as storage location. Only thing is that in case of 1 or 2 is fixed, as per that correction you see, then we have to run this conversion report for transferring these storage locations and creating these as MRP area. Unfortunately, I cannot show you because somehow this report is not running in this system. The initial screen is coming and it has now introduced a test mode also for this storage location migration to MRP area on the S4HANA side. Now, when you execute, nothing is coming. I've checked the SAP note. They have given a Z program for that one, but that is also not available here. So, maybe that this training system doesn't have, but SAP has given this program for migration of those storage locations to MRP area. So basically, the steps are like in ECC, we are running 1-2 programs and then setting up the MRP area. Now, in case storage location MRP is there and MRP area planning is there, in S4HANA side, MRP area is already set up and pre-delivered. We just have to set up the MRP area, define the MRP areas and assign to the material master and do the MRP area planning. If we do MD01N, it will automatically plan in MRP areas. So that is how the storage locations are excluded. This note tells us about all the, upgrade checks related to PP MRP area. And all the correction instructions and the programs this has to be implemented. And that program to convert storage location to MRP area, therefore migration, is this one. This is the program that you run, the report you run for your pre-upgrade check. So when you run this, it will tell you the readiness of your system. I mean, whatever you are using, whether that is ready for your, conversion, whatever is ready and whatever is not ready. So it will give you a list. Now, I'm not executing this, but when you execute this, you will get a report on the relevancy check. In online you can get, and if you execute, you will see the list of things which are ready and list of things which are not ready, and the errors and what you need to do. I mean, there can be manual configurations, post migration, there can be pre-checks, there can be notes that need to be applied. So that is what it will give. Now this is the first step for migration pre-check activities. And secondly, for PP MRP, that correction note has to be implemented. And then for the storage location MRP, this is the procedure. For migration, you have to run that program. They have given one, we have already discussed. Let me go to that training material which they have provided. So this presentation, including examples, images, references, are provided for informational purposes only, complying with all applicable copyright laws is the responsibility of the user. Without limiting the rights under copyright, no part of this document may be reproduced, stored, or introduced into the retrieval system or transmitted in any form. Credit shall be given to the images taken from open source. Okay. So MRP in S4HANA, what they have told, we have already discussed. Planning run, this is the summary. Let us summarize. MRP controller level not possible. Why it is so? Let me go to S4HANA system again and go to that MD01 screen. So we see that MRP controller level is available. I don't know why this is given. Immediately for plant say 1710, I will run at MRP controller level. Let us say this one. So the first statement that is given in the slide is wrong. We can run at MRP controller level rather. So this will give you the log. You can get the material list. You can get the materials with messages. If you look at the material list, you will get whichever materials are planned. These are the materials that have been planned. Now here you will see that these materials are run on successfully planned on MRP live. And the MRP time, processing time is also written here.
And what is the classic MRP? What is the difference between?
We discussed that certain materials could not be run on live MRP. So the system automatically switches to classic MRP for these materials. So there are some issues. So where are the issues? That is right. There is some scheduling issue. That we have to see, find out. We have to go to the material master, see, and that MRP check for this material, that program we have to run. Yesterday I gave a program. So we have to check that program, MRP check, PPH. So we have to find out what the issue is, why it is not suitable for MRP live. Similarly, there are some scheduling issues for this material as well. And for this material, there is some other issue. So these are switched to classic MRP. Remaining materials have been run on MRP live with the processing time. These materials were picked up but not run because nothing has changed. So that is why these are not run. Now regarding the material with messages, if you click on that, you will get all messages, whichever is No, I mean, this is for 8. That is termination or some problem. So there is no message here. So if it was there, then we would have selected that and solve issues, and that would have taken us to the, let me see if we can do it for some other plant. So this gives you again that information. I mean, we don't have any error messages, looks like. Let me see. Now, here you have the warning messages. And information, material status 01, material should not be used in MRP planning run. Source of issue, MRP live on HANA. So material status 01 or 04 should not be used in MRP. So this is a warning message, but I think the plan happened. No error message has come. So let me see if what is there. So if I select this material and do the solve issue, no standard solution available. I don't know what does that mean, but if there is an error, it would have taken us to the issue. I think for warning, it is not error. If we go to the material master, we have to see that material should not be used in MRP. Let me do one thing. Let us go back to that program prior to running this. That was, I think, MRP check. This conversion record, check and correct planning file entries. This conversion report for old MRP records into new. So once that, here no record is found. So we can put some other plant. Nothing is there, no record is there. I mean, for conversion into new. So basically, if we go back here, so planning run happens. So after planning run, we have the stock. We can go to individual stock requirement list. The planning run gives us the time, HANA database time that it takes for the processing. It gives us the material list which are planned. It gives us informations on the materials that are to be, that have been planned, and for materials having issues, that list is also there. I'll give you that program name for correction of that issues. I forgot yesterday, day before yesterday I gave. I'll just collect that. It is there somewhere. So it is not true. The first statement of MRP controller, classic MRP, it is not possible. It allows at the MRP controller level. Now, STO requirement is not known in the supplying plant until the material is planned in the receiving plant. Here, it is from the scope of planning, we have to enter in that case. So in S4HANA, we don't have the scope of planning. It automatically takes, in case of STO, for the supplying and receiving plants, it is basically the priority, the sequences. We take the source first, and then it plans the sync.
No, but if under one company code, so there are multi. Sorry.
If I go back to this MD01 in screen, so in variant you can just create a variant. You can create for here you can include the plants. Planning mode is a required entry. Maybe stock transfer requirements also you will consider. This one. This program which I put it in the. This range of plants, material, product group, these are possible. MD01, you don't have that. No? You cannot give the range. If you want to include certain materials, there is a user exit key at the bottom, no? And the user exit use for including those materials, which is not there in MD01N. But already the range of plants or materials you can select here. So for that, no enhancement is necessary. But in MD01, you have to do that enhancement and assign that user exit key. Also the planning mode, there are 3 planning modes. Here it is only 2. and it is 1 normally, or 2 for delete and recreate data for changes. Regenerative planning you do as well, it is being replaced here. It is put here only. And the other option is this this gross creation, as you were telling, this creation indicators are not available here. If we look at this PPH MDBM table in S4HANA, you will see that just 1 second. It is not, and also the number of materials is a factor, and also we have told you the number of low level codes. I mean, more the low level codes, so that is why there is a program to optimize the low level code. Each time a BOM item is added, a new low level code is created. So that has to be optimized, or unnecessary deleted low level codes need to be deleted, assigned. I mean, so these things affect the performance. So threshold is, we have seen that 100 materials is the minimum threshold. Below that, it is worse. In MD01N, the performance is not good. But if the number of materials is very high, and if there is less bifurcation between MD01 and switch, between MD01 and MD01N, then the performance improves. So in the planning file, we have seen that all these indicators are there, but this net change planning in planning horizon, that indicator is no longer here because planning horizon is not supported. We are always planning the entire material, but due to the table access, faster table access, because every procedure is running on the database for retrieving the data and then doing the calculation and running, giving you the output. Everything is on the database. So in any case, the timing is less. So that is why we do always include all the materials. Not only because it was originally intended to include only materials in the planning horizon in case there are some restriction. Restriction is necessary. Always we will not plan all materials. Whatever planning horizon we declare in MD01, the materials will be included in those. But here that is not required. Since it is run on the database, anyway it is faster. So that is why they have dispensed with that this indicator. So so you see that we can include several plants and meaning of these 4 new fields is explained in this note, but this note is not available. This note is not yet. This is January this year. Acha, MRP list is not there. We have seen that MRP list is not created. If you run this program, and now after running the MD01N, if you want to see that the MRP list is generated, you will not see. It is saying no MRP list. So it does not generate any MRP list. They are saying that you have to go to stock requirement list. Also restrictions on MD50, MD51. These transactions are available, but do not run. For WBS element and sales order based. This has to be optimized. This will be taken care of if it will switch to this classic MRP and run this program. MD050, MD50 and 51, as well as those MS transactions simulation, that has to be optimized. And for optimization, some procedures are there. I'll collect everything and give it to you because I don't have everything in a place. So creation indicator for purchase requisition and delivery schedules are used in old MRP. Here it is always purchase requisition, but you can do that if you go back to classic MRP, and you can also change the procurement type by using a body, which is an ABAP managed body. I'll give you the name of those bodies. So we have done this planning run on MRP controller level. This was the old screen. This we have told that is this one. This is the planning file setup file. So if you run this program, we have this program, but for this This is P for planning file entry. This is the setup program, PPH setup. Setup MRP records. This one. So it will update. If you don't give any plant, it will set up your materials which are not, which needs correction or updation in the MRP planning file, PPH DBBM. Why there is only one material? So it gives a log of total 3129 materials have been checked. We see that only one insert, that new material which came in the initial screen, that is the new record that has been written, but update made for this many materials. So that is how you set up the planning file instead of writing, instead of running those programs. This is good. This is better. For long-term planning, same thing. You have to run this simulation program. Plant table, that MRP indicator is set. So whenever we create a new material, it is included in the planning file. But there are some corrections and adjustments may be necessary. So that is why it is run at a predefined interval as a background job to set up this file. So next is we have discussed that NETPL is not available. Planning horizon not available. This you have to run periodically. Remaining all MS transactions are working. Some optimization is necessary. And for that optimization, whatever is necessary, there is some enhancement or some BOM. One important thing here is that whatever enhancements that we are using in the MRP planning run area, that will not be supported in S4HANA. So custom code remediation is a must and custom code correction, number one. Secondly, in case of bodies, none of the classical bodies, I'll give you the list, will work here. So you have to replace with that above managed database procedures, AMDL bodies. That some lot sizing procedures like cost-based procedures, optimum lot sizing procedures, group procedures, these are not supported. Like MRP type VB for forecast-based planning we normally use in ECC, but in S4HANA we don't have that. Let me go to any material master. VB is still there, but I have not tested this. But PD, P1 to P4 are, used, that is normal. But whether VB can be used, I don't know. But basically, we are doing advanced planning. We take the advantage of advanced planning. There we'll use this seasonal one is not working. No? This VM. Automatic, no, not VM. The seasonal, this one, VS. These has some restriction. These has some restriction and this cannot be used. See, these transactions MP30, MP31, MP32 are used. What is MP? These are forecast. Normally available but not considered as future. One issue I have faced while doing this is that here, if we want to upload 52 weeks demand, how do we do that? I'm talking about classic also. There is no change. Actually, through LSMW, we cannot do because this screen is recorded. So 12 weeks, if we do weekly bucket or weekly bucket, then 12 weeks possible. Now we'll talk about the sourcing part, external procurement part, is simplified sourcing. So what has changed here? Sourcing has got simplified. Sourcing means, I'll tell you, there are sourcing means both internal and external sourcing. In case of internal sourcing, it is only the production version that comes into picture, nothing else. So here SAP has a simplification item. So I'll tell you what is the new simplified sourcing says. And for external, you have again those things. That is the purchase related master data like info record, source list, quota arrangement, contract and scheduling agreement. So how that happens, I'll tell you briefly. Just give me 2 minutes time to gather some information. I have some information here. So basically, production version is the only source of supply in case of internal procurement, and it is a mandatory thing. So for external procurement, you will see that source list is no longer taken into account. And in your info record, you have an indicator now for automatic sourcing. Let us see if I can find any info record. This indicator. When you tick this indicator, this info record is always taken as a source of supply, and we have the source list from higher versions, but that is not taken as a source of supply anymore. I mean, when we do the procurement, our procurement for external procurement, our things like lot sizing procedure will decide on the quantity to be procured, and your scheduling dates are determined from MRP, and finally the source of supply or assigning the vendor to the purchase requisition or source of supply will depend on certain priorities they work on. So firstly, I mean, this automatic sourcing indicator, if you select, it is not required to maintain a source list separately. Earlier versions did not have this source list at all. But now they have given the source list only for that blocking of vendor facility. So that is one simplification. In the source list, you have this automatic sourcing indicator. So then it will be considered as a source of supply. For internal, it is always production version. For external, it is the automatic sourcing indicator. And if I go to this MD01 in for external procurement, this for external procurement for material having F, so that takes the procurement type. If we have a scheduling agreement, then the delivery schedules are automatically generated. In MD01, we have this earlier, these indicators are no longer available, but it automatically takes, like the schedule lines. But here in case of MRP Live, these indicators are not there, but if we want to generate automatic delivery schedules from scheduling agreements, so that scheduling agreement will have to be having a release documentation. I mean, when we create a scheduling agreement, this LP is not supported. LPA is supported with release documentation. So in your legacy system, if you have LP type of scheduling agreements to be treated in MRP, all have to be converted to LPA. And there is conversion program for that. So system will look at LPA type, and based on the quantity and your provided the scheduling agreement exists, it will just give you the schedule lines as output from MRP. Another thing is that this quota arrangement usage. If you go to the material master record, Previously in ECC, there was I'll just open ECC again. This field, quota arrangement usage, it must be maintained. Then the quota file, if you maintain in MEQ1, and you can enter for internal, you can enter a production version, and for external, you can mention your scheduling agreement or contract or info record in that quota file. And also you can select whether it will be a splitting quota or allocation quota type of quota arrangement. But this will not be considered unless you maintain the quota arrangement usage in the material master. But here in S4HANA, this field is no longer available. It has been simplified, and quota file is always taken into account provided it references your info record. In quota file, when we maintain, here we have to maintain the supplier. Here for internal requirement, we can maintain the production version, and for external, we have to maintain the info record. Then it will be taken into account, because in S4HANA, this field is no longer available. So that is a few things about simplified sourcing. Actually, we can create a test case, some test scenarios, because they have not given you anything they have not given you anything for this lab. These are not there. Module apply lead time. These were old things. So for new unrelated transactions and system run, they have not given anything. So these have to be given so that we can test certain test cases in the system. So basically, it is MD01N versus MD01 pre-checks in PP area, in the MRP area. So what are the pre-check activities, that what are the simplification items, what changes have taken place, and in case of the issues, what action we need to take in the different areas that we have discussed. So this is the basic that we are discussing. It is one part is telling the client, making some POC. The other part is from the consulting point, what pre-checks we have to carry out, what readiness checks we have to see, what actions we have to take pre and post migration. All this will be summarized, and this document will contain that. This document, particular document, is giving you features, but what steps we need to take, and the different reports that we need to execute, that is still not there. I'm trying to collect and give you the simplification item names and the note numbers, from where you will get all the details. Strategic decoupling point identification and then calculation of the buffer zones. There are basically 3 buffer zones, that is green zone, yellow and red. Below that there is another red, and at the top of green zone there is an excess stock. So first step is positioning of the buffer, and secondly calculating the width of the zones. So how we calculate the width of the zone? That is through some formula. After that, these were our different zones. Green zone is the OK zone. Yellow is we have to rebuild, or rather here we have to reorder. And the red zone is the alert zone, and stock out zone is the below red zone. So first step is calculating the green zone buffer. See, one thing I am showing you. This is my test that will execute in the system. These actually are the steps. These are DDMRP steps that will. These are the steps. test script. So you can run the cycle. First is buffer positioning. That is how we identify the decoupling points. And for that, these are the theory apps. Schedule product classification, then mass maintenance of products, then checking of buffer positioning. We'll calculate and the buffer positioning for protection. These are the theory apps that we'll do. After that, this is the buffer sizing where we calculate the width of the zones, this one. So these formulas are inbuilt in SAP. I mean, we have to maintain the lead times in the material master, and from there it will get calculated. We have to schedule lead time classification of products, buffer maintenance profile, schedule buffer proposal calculation, and then we'll manage the buffer levels. These steps we have to do. After that, once this is done, then we'll do the run, DDMRP run. Up to this buffer sizing. I mean, up to this buffer sizing is our configurational apps. See, here you will see in the system this calculation and the sizing. So after that, the second part will come, that is through MD01NN, we'll run DDMRP and see how it works. So let us continue and complete this slide first. Adjustments. Whether a proposal will be created or not, and if created, what will be the quantity of the proposal. Now, under demand-driven MRP, first we have a part type designation in DDMRP. All the parts can be classified basically into stocked and non-stocked parts. Now, for the stock parts, this can be replenished override, and min-max. Now, so replenished parts are strategically positioned items where buffers are managed by using color-coded buffer zones that we have seen, together with the DDMRP buffer management logic. The replenished override part are strategically positioned items, replenished parts, but with a difference that the size of buffer zones is fixed. And we do not have dynamic adjustment for these zones. So these parts are used in situations where there exist certain limitations over the sizing of the buffer zone due to limitation in space where parts are stocked. So due to this, we have a fixed zone with no adjustment. The limitation of buffer zones is only way to keep in control that the physical limitations are adhered. The min-max part are less strategically important, which can be managed with our conventional reorder point planning. Minimum level is the reorder point and maximum level is the order up to inventory level. In case of we assign the accordingly the lot sizing procedure replenishment up to maximum lot size. The replenishment order is recommended when the on-hand plus on-order inventory is below the minimum level, where the size of the replenishment order is defined according to the gap between the minimum and maximum. Now, non-stock items are non-buffered items and lead time managed items. So, non-buffered parts are greater proportion of all parts in manual inventory belong to non-buffered parts, which are non-stock items and managed with conventional MRP. And lead time managed parts are strategic non-stocked items managed with similar kind of color-coded buffer zones as replenished and RO parts, but their difference is that parts are made MTO instead of MTS. DDMRP use time buffering for LTM parts, lead time managed parts, instead of stock buffering. The planning and order generation logic for non-stock parts is based on backward scheduling of customer orders, but by using lead time of parts in the BOM structure. Both lead time managed and MRP managed parts generate supply order when there is an existing demand for respective parent level parts whose due date is used to calculate the planned release date of the parts. The difference between lead time managed and MRP managed parts is that the lead time, there are inserted time buffers in the product structure to dampen the system nervousness and enable more reliable due to the date performance. These things, when we'll do the DDMRP, we have in our BOM structure, we'll have to see. In this scenario, mostly stocked items are there. So, LTM parts or non-stock parts, we have to see how this time buffering, I have to test in the system, how this time buffering will come. Parts are classified as LTM parts when buffering with inventory is not feasible solution due to highly irregular demand of SKU or due to high level of customization. In such scenario, time buffering can become feasible alternative solution. Where to place time buffers is based on the BOM structure and the longest unprotected path in the structure, that is known as RLT, synchronized RLT. So this is used to free the SLRT path from disruptions. This is an example of time buffer. We have the yellow boxes, the FG101, which is 59 days. 59 means 10 plus 5 plus 6 plus 8 plus 30. This is the longest part. So this is the ASRLT for this FG101. 38, 44. Now, that is a very long path. Now, if we are to free the path from any disruption, the feeding lines will be given time buffering. For example, SFG301 has two feeding lines, and one of them is on this longest path. That is SFG401. So, to secure that SFG301 is assembled as per planned date, we need to ensure that raw material 401 is not delayed beyond the limit. So that is 45 days. Similarly, FG101 has three feeding lines with one leg on the ASLRT, that is the yellow part. So we need to ensure that SFG202 and 203 are not delayed beyond the limit, because this yellow line is the ASRLT. So anything other than this should be given a time buffering. And since this is the longest part, so others have to be assigned that time buffering, so that the disruption does not happen in the ASLRT path. So in that case, RM401, SFG202 and SFG203, these are LTM parts with time buffers, and we will have to assign time buffers to them. Now time buffer is calculated this way. 25% of ASRLT of buffered leg. That means for SFG202, it will be 25% of 15. The time buffer is divided into three zones. The green, yellow and red, where the size of each zone is 1/3 of the time buffer. These zones are later on used for monitoring duty. The ASRLT of SFG203 is 31 days, that is 6 plus 25. Why? Because time buffer is 0.25 of the ASRLT of the buffered leg. So for 203, our buffered leg is 201, this one, this leg. So that means 15 into 0.25, that will be 4, 5, while it is 6 plus, I'll check this calculation. SFG 203. SFG 203 has a ASRLT of SFG 203. That will be 25 here, 25 plus that itself is 6 days. That is 31 days. Right. This is the ASRLT of SFG 203. And that has to be multiplied by 25% of the buffered leg. That is 31 into 0.25. That will be time buffer. That will be assigned is 8 days. Similarly, let us see whether that is 12 days for 202. So for 202, it will be 35 plus 7, 42 multiplied by 0.25, that is 11 point something, so it will be 12. That way this time buffer is in the green icon. So basically, if we leave the longest path, which is the yellow path, all other elements has to be assigned a time buffer so that the yellow path is not disturbed. And sufficient time buffer has to be given to other path. Visible final step is the visible and collaborative execution. In MRP, due dates are the basis for priority planning since there is no clear visibility of actual and relative priorities. DDMRP challenges this priority setting since it pushes organizations to focus on due date performance, which does not always correlate or support organization to maximize flow and ROI. Instead of focusing on due date performance, the DDMRP proposed that material shortage should be the major performance indicators. MRP prioritized by date and DDMRP prioritized by buffer status. Now there are some execution alerts in DDMRP execution. Buffer status alert and synchronization alerts. Current on-hand alerts and projected buffer status alerts. These are alerts. There are Fiori apps where we can see the alerts. I mean, in the after the run, we can see these alerts after execution. These are basically scheduling and exception messages that we see in the standard MRP. Difference with conventional MRP rescheduling message is that on-hand alerts provide priority of expedite time. When there are multiple orders to be expedited, it indicates the parts which requires most attention based on the buffer on-hand status. This I'll provide to you, this slide. Let us not go further into this slide. These are factors which we'll see. More of a theory and for customer presentation. So what is what is the DDMRP process flow? Demand driven sales and operation planning. It starts with DDMRP SOP. So model and part parameters, that is master settings. That means decoupling, buffer size calculation, buffer profile maintenance, these things. After this configuration is done, the settings are done, then we run demand driven MRP against the actual demand. And it also we do the demand driven capacity scheduling. And then the demand driven execution. Let us consider this simulated case. We have the supply orders on the left, and on the right we have the sales orders demand in blue, and we have the blue line, pillars are for order spike threshold. Now this is the current buffer zone that we are having. Our purple line is the present stock and available stock, and on hand stock is the stock that we are having, on-hand stock is the stock of available stock plus our expected receipt. So that is denoted by light blue. Now our parameters that are given information, synchronized RLT 7 days, lead time factor minimum 0.5, average daily utilization or consumption, that is 10, variability factor 0.5, order spike horizon is 7 days. We have x-axis for the number of days, and order spike threshold, that is the y-axis value, that threshold, that is 26. So with this condition, as time progresses, sales order and supply orders advance towards the buffer. So what is the 37? Day 1 is the situation, 127 is the available stock. There is no supply order. On-hand stock is 65, open supply 72, and sales order demand is 10. How this available stock is getting calculated? First day it was 127. There is no supply order. On the second day, supply order is 78. So available stock in the green zone, it is 127. Now it has come to the yellow zone because of the sales orders, 78 supply orders. So available stock, top of yellow zone is 122. So the available stock 79 is somewhere, the width of the zone is 70. So 122 is the top of yellow. So it will be somewhere where the purple line indicates. Next, that means at this point, our MRP will do the procurement, and the available stock at the green zone as is in the green zone now. And the top of green zone is 157. Aim is to have the stock replenishment up to the top of green zone. So it is somewhere in between. It is 140. And we have sales order demand of 47. So 17 plus 6, 23, 28, 37, 47. And no supply order. Here we had a supply order and there was a replenishment. So our available stock was 127, somewhere at the lower of the green zone. After that, the supply order fulfilled, and because of the sales demand, ultimately it is at the middle of the yellow zone, and after the supply order replenishes, it goes somewhere in the middle of the green zone. We still have sales order demand of 47 and no further supply order. So the first 6 sales order demand is replenished. So it has just come down below and almost reaching the top of yellow zone. And now we have a sales order demand which is reduced to 35. These are spike threshold, sales order spikes. Now further sales orders are being met in this yellow zone. And now we also have a supply order. So it goes further increase to almost top of yellow zone. So, but the consumption of the on-hand stock, you see the on-hand stock was in the red zone from day 5 due to the sales order consumption and spikes. So first one consumes and it becomes 49, and then it goes to under in the yellow red zone, because the width of the red zone is 52. So further consumption of another 5, it now comes to 44 and it is within the red zone. Now further replenishment happened in with this supply order of 37 and the on-hand stock is again in the yellow zone. And total sales order demand is 40. So this way, this on-hand stock level and available stock will fluctuate between the green zone and yellow zone. And so we have considered a 15-day situation, and after that we can get this linear representation of these figures for over these 15 days. We have on-hand stock, we have the supply order demand, sales order demand, and we have the available stock, and we have these figures are obtained from the previous slides. We have the open supply. Actually, these data we have calculated from the Fiori apps. So when we run this, we will get these figures and I'll put it here and we can do the simulation. This first part is the theory and concept and for client presentation, and this second part is what actually happens, what we need to do in SAP for this demand driven MRP replenishment part. So what we need to do is these settings. That is, these are actually available in S4HANA without Fiori apps also. So we have to do this parameter setup first. We have to update this table PPH DD active V. We activate demand driven replenishment here. First thing, demand driven replenishment has to be activated in the system. These tables we have to activate demand driven replenishment, and we have to define the profile. This is the lead time calculation method. We'll find this part later on. So we have to define the profile which will store the parameters for buffer calculation. What are these parameters? This parameter setup is mainly the order spike horizon, which we have defined earlier in our formula. And this spike horizon parameter multiplier and the threshold parameter multiplier, that will determine the this is a function of the red zone and the SAHM into DLT in the earlier formula. So these things are already calculated and these parameters are finally updated in this profile assignment table. One is the spike horizon and another is the spike threshold value. Now different plants can have different set of parameters, of course, depending on this dependency. Now next, these are setup tables which we have to update in the setup of DDMRP. Normally we have done this through our Fiori apps, but in GUI also these are available. So this table maintains the variability factor and lead time factor for materials with different procurement type. Variability indicator and lead time indicator. Next, there are some jobs that need to be set up in customizing for buffer type classification and buffer proposal calculation. So basically, we are having this set of Fiori apps. Earlier I showed you that Word document, these Fiori apps you have to run. Schedule product classification, the classification is based on these 3 types. So we'll see that. Then mass maintenance of product, schedule lead time classification of product. This is the positioning of the buffer. Then we do the buffer level calculation and manage the buffer levels for adjustments. And finally, we do the MD01 in replenishment planning and replenishment execution. So first, positioning and protect. These are our configurational theory apps. And the other one, that is the pull, that is basically MD01N. So Fiori app for schedule product classification, that will do. With this app, you can classify your products. 3 types of classifications are there: ABC classification, PQR, and XYZ. Depending on ABC is for goods issue value. BOM usage is PQR, and variation in actual demand is XYZ. So based on that, we first classify our product. Second is the mass maintenance of product. Here we can display and change product details relevant to DDR. That means material master records. Select products that are relevant to DDR with MRP type D1. Mark your selected products as DD relevant by setting the appropriate MRP type D1. Based on the product classification, we'll select the products and mark them as D1. Display and change the results of product classification. Select an average interval based on which the ADU and decoupled lead time DLT are calculated. These are the calculations that happen in this period. Select which lot sizing procedure the system uses within material planning to calculate the quantity to be procured. Set a minimum lot size to define the minimum procurement quantity. So this is basically maintenance of the material master, where we maintain these things. We will maintain the MRP type, we will maintain the average daily usage, average inter and decoupled lead time, lot sizing procedure, and the minimum lot size. Then we'll do the lead time classification of products. It will calculate the lead times.
Alright, let's test your knowledge. Which of the following best describes MRP procedure changes in S4HANA? Option A, MRP run frequency reduced. Option B, lot sizing procedures are simplified. Option C, planning runs and executed in real time. And option D, accuracy of demand planning is improved. Take a moment to think, and when you're ready, choose the correct option. And remember, each choice holds a key to unlocking the answer. So good luck and type the correct answer in the comment section.
Next theory is the schedule buffer proposal calculations. That is calculating the width of the zones. As per the earlier tables, the factors that we have maintained in the tables, this will be calculated. So for that, we already have the previous 3 theory apps done. That is ABC calculation, XYZ, and PQR. We have identified and marked the DD relevant product, and we have classified based on decoupled lead time, and we have scheduled lead time classification of products. So it calculates the average daily usage of the products over a selected averaging interval, in which is set in the previous mass maintenance of products app. So calculate the DLT over the same interval in conjunction with ADU. I mean decoupled lead time. And then it generates the buffer proposals, which will act as input to manage buffer levels app. I mean the next theory app. So adopt the generated buffer proposal automatically. Now, this will fine tune the buffer levels. Any app, when we'll be using the Fiori apps, area of responsibility has to be set as planned in any Fiori apps. Otherwise, you will not get the reports or you will not be able to execute also. Your area of responsibility at plant level, that has to be set. So Fiori app for manage buffer levels will view the buffer level stock. We can adopt the proposals which have been given for buffer level calculation from the last step. We can ignore the proposal. We can manually adjust the levels. The buffer zone, buffer levels, average daily usage, decoupled lead time classifications. And we can adjust using changing the adjustment factors. Now, MD01 run will happen. So it's Fiori app planning by planning priority. So it will calculate these 4 equations it will use. One is the net flow positioning, that is on hand stock plus open supply minus qualified demand. So proposed quantity is equal to maximum stock minus net flow position. First, the net flow position. The net flow position is the on-hand stock plus open supply minus qualified demand. Qualified sales demand, which contains the regular sales demand plus spikes. So proposed quantity will be maximum stock level minus net flow position. There will be a planning priority, that is net flow position by maximum stock into 100. Demand driven MRP does this based on this planning priority. And on hand status will be on hand stock divided by safety stock into 100. Output is this one. We have these figures calculated. Planning priority, on-hand stock, open supply, qualified demands, net flow position, all this will be calculated. The red ones for which the correction needs to be taken. So with this app, I can view today's stock situation for each product and check that a sufficient on-hand stock is available for production. So we can speed up replenishment by contacting the supplier or the production supervisor. If the position is good, then we can expedite our production. When we run MRP live with specific lot sizing procedure defined for DDR is H1. Replenishment up to maximum. Previously it was H only. Now we have H1 against D1. It was HS. HB. Now what is the difference between HB and this HB is used with our conventional MRP. H1 is used with demand-driven MRP. So we do the MRP run, different segments in MD04 screen. Earlier, we did not have these segments in other MRP runs, but we have a segment for end of spike horizon and end of planning time. Planning time fence is there. So DDMRP will use this lot sizing procedure and creates a replenishment proposal based on the information. Impact of lot sizing procedure. If we use EX, top of red is 101, top of yellow is 157, and top of green is 203. Stock is 21. Net flow is 49. So if we use EX, our proposed is 154. So top of yellow minus net flow, that is the lot size in case of EX. Top of yellow is 157 minus net flow is 49. So it will be 109. For HB, that is up to maximum stock level. And H1 is also up to maximum stock level. Let us see. So as per calculations, our proposal is 154. Now when we use HB, our lot size is top of green, that is up to maximum stock level minus stock. So our stock is 21, maximum, my top of green is 203, so it will give 182 rounded to, and that is maximum. So overproduction. But if we use H1, our formula for the lot size will be top of green minus net flow, not the stock. So as a result of that, what is proposed will be matched. So for DDMRP, when we are using this net flow, we use H1. In the stock requirement list, when we do DDMRP, we'll be able to see the demand-driven replenishment calculations, like safety stock, reorder point, maximum stock level. These things are shown. But apart from that, these new things like decoupled lead time, order spike threshold, order spike horizon date, that can be seen. Actually, I will give you the step-by-step procedure and will run in the system also. Then you will also run and calculate, and for one material you can just do the manual calculation and check whether these values are matching. So there is a separate tab in the MD04 that is for demand-driven replenishment. These are important tables for demand-driven replenishment, which will contain these parameters and values which are getting calculated.
Course introduction. Course page. Hello everyone. I wanted to provide a brief overview of ZaranTech's training program for SAP manufacturing on S/4HANA. This comprehensive course covers key concepts and tools you need to optimize production planning, execution, and monitoring using SAP manufacturing on the S/4HANA. Over the past few years, hundreds of professionals have leveraged ZaranTech's SAP manufacturing on S/4HANA course to expand their production management skills and advance their careers. After completing the training, many have graciously shared their success stories on ZaranTech's testimonial platform. In just a few weeks, you can learn how to configure bills of material, schedule production runs, track inventory, analyze capacity, and connect supply chain data in S/4HANA. This can open doors to new manufacturing roles or help you deliver more value in your current position. If you want to learn more about SAP manufacturing on S/4HANA with ZaranTech, visit the link below of the course details. Getting started now with the training is a smart investment for anyone looking to boost their expertise in SAP state-of-the-art manufacturing solutions. Thank you for listening.